Hello, everybody. Let's see here. Gonna do this quick, I think. So, okay, let's get into why I'm doing a stream today at all, even. I just kind of felt like it. So, I was asked by Uniton, um, a little while ago, maybe a couple weeks back, do a tutorial on like a Limbo plugin, like Hypixel's Limbo. Uh, and also, so that's what we're gonna try to do today. Hopefully, we can get some stuff done today. We're gonna start from scratch. So we're gonna do. Um, there you go. All right, spread the word around, and all right, I think we're ready to go. So let's go ahead and. Hello, I'm here. So, this is actually my first coding stream with the model. Third stream overall with it though. So, we're on my laptop monitor today, because my coding things usually are. But I didn't feel like changing my aspect ratio again, so my laptop monitor is 16 by 10, and my big monitor that is just streaming Subnautica on is 16 by 9. So we're gonna have to deal with some black bars on the left and right today, but that's not too bad. So this is gonna be a very short stream because I actually have to go somewhere in like 2 hours, 2.5 hours maybe. Might have to end stream before that. It might be abrupt. Might be an abrupt ending, but I just wanted to get this done. Not done, but I wanted to get it started. We're gonna go over some packet blocks, basic, packet stuff. Creating a new world. I believe I did this in Andrew Prison streams as well. And we're gonna go over starting a test environment server, just from scratch right now. So, I already got a little folder here. I have it behind me, with a little run.bat. There's nothing else in it right there. We're gonna do a 1.20, 1.11. So let me go ahead and get my out of the way here. Here we go. Just gonna get myself down. There we go. Just gonna be down here in the corner. Let me know if the music is too loud or not. I'm using different headphones today because because I'm going somewhere and I didn't want to have, big headphone hair. Also, my microphone is in a little bit of a different position today. My Subnautica streams, I would put it in front of me, in front of my keyboard. But that limits my ability to type really. So I put it off to the side a little bit. So hopefully it doesn't sound too bad. So first things first, we're gonna start with paper MC. I believe it is. I'm gonna go there. We're gonna download a server jar. Also, I apologize if my stream or computer isn't performing too well. I didn't restart it before this, so anyways, we're just gonna download that, and then not this stock. We want paperweight user dev, and that is here we go. These docs. These are very good docs for starting a project for documentation. Okay, so I'm gonna get the jar. Let's start creating a server here. So this is now the folder. We got the jar that we just downloaded. I'm gonna rename it paper because that's what's in this run.bat here. I'm gonna do a new text document ula.txt. Open that up. Okay. Simple. You're just gonna do. Agree to ula. Okay. Save that. Close that. Okay. Now we can run. All right. So I know a lot of people like to, as much as they can, they like to, oh yeah, I gotta fix my Java version here. That's annoying. Let me do that. It's in my environment variable, so. Gotta edit my system environment variables. Variables path, let's see. Because I just installed Java 8, like normal Java 8, not like Eclipse Eternum or whatever. Because I needed it for a school project or a school assignment. Pac-Man game I was talking about in the Subnautica stream. Where is this? No. I don't see Java in my environment variables anywhere. Okay, I guess. Okay, here we go. It's in the system. Okay, I think I just have to move it down. Move against Java. Normal Java. I don't. Okay, I think I just have to change the Java home variable then. Well, no, that's still 21. What's going on here? Open the folder in terminal. Check. Okay, dogs are barking. Okay. Sorry. What's going on? Is my question here. Why is it trying to use the old Java version? Where's I don't even see it in my environment variables. That's the problem. So I don't know how to change it if I don't know where it is. This is a mess. Let's see. Okay, I think we just have to do. I'm gonna try opening terminal, and I'm gonna do. Find my Java stuff. Sorry, it's my. Shouldn't take too long if I can figure this out. No. There we go. Let me check my current Java home. Yeah, okay. Copy that. now. Put these clothes. In no, in why? Alright, let's just try this again here. Nope. Okay, why? Why? How do I? Alright, well that doesn't work. Why? No, I don't want to change it in Eclipse. I want to change it to. Okay, no, it's ridiculous. Java home. I don't want that there. Okay, do I have another Java home something here? I'm really trying to find why it's targeting Java 8. It's in. I only have one Java home system variable, and it's pointing to Java 21, not 8. Okay, I think that's why. I think path here, yeah, it's pointing to Java 8. That's why. I need to move. I need to change path. Or move it. I'm gonna try to move it down first. See if that works any. Okay, yeah, it did work. Okay, so all I had to do was move it down in my environment variable list. I didn't have to change path, like system variable or anything. Alright, got that sorted. It's now downloading all the files we need. So I know a lot of people are saying they don't like having a test server that they have to shut down and change the plugin out and then start back up. I think that's ridiculous. I think you can do it. You know, it's not that bad. I'll even show you how to make it more efficient starting up and down. All you have to do is delete the 2 other worlds you're not going to be using, right? And go, I believe it's spigot.yml. No. I know they just changed it. They just changed something about allow. Right, because I don't see like allow nether in here anymore. You're just gonna disable this worlds basically. Let's see. Bucket.yml allow end. And that defaults. And I believe that it was keeper world defaults. No. It might be in just paper global. Or it's in the, oh yeah, here we go, enable nether false. They just changed that. So that might be it, what we're looking for. Then we can run again. And it shouldn't try to load those worlds because we just disabled them. Yeah, there we go. Much faster. We also don't have any plugins right now. I'm gonna just copy over some plugins from my other test server. So we're gonna go plugins. There you go. Alright, there we go. I copied over essentials. Fastest sync world edit, placeholder API, and world. Right, there we go. It should be ready. Let's test it by running real quick. Okay. Yep, everything is loaded. Plugins are all green. Alright, we're good. Okay, so that's our basic little test server there. Let's start creating the new project. This is Bamboo Prism, but we're going to create obviously a new one. I'm going to put it in tutorial here. I'm going to call it Limbo. Limbo. Event settings, make sure you're using Gradle you want. Whatever. I'm going to do the group ID is my GitHub. Not going to create a Git repository. Java 21 and create. Okay. So this stream might not be too long, as I mentioned before. We're just gonna, you know, get a start. The music 2 lab, by the way. I know nobody's in chat yet, but I hope it's not too loud. All I can say. Okay. Now we have our basic setup. Not sure why everything's yellow. I think it's just loading still. Perhaps. Reload. Yep, there we go. Good. First things first, let's get paperweight in here. Copy that. And I am not one who likes Hotline DSL version. Keep it like that. That won't work. Even though I just wrote it, I need to add the dev bundle. So it'll actually work. There you go. I believe we might need a better higher Gradle version. Does this require latest version of Gradle? Yeah. Let's see. Do we have? What is the latest version of Gradle? That's what I'm looking for. 9.4.1. So let's uncomment this stuff because it won't work if we have it in still, because it won't build. And then terminal. Let me check here. Yeah, see, I got a lot of different stuff here. Okay, so this is the command we're gonna use right here. Instead of 9.2.1, we're gonna use 9.4.1. Just like that. dot slash Gradle wrapper dash dash Gradle version 9.4.1. It's pretty much just release. Should do that. And then enter. And then this should upgrade our Gradle version. Because I don't know why it doesn't let us select it from the project creation screen. So there we go, that's successful. Now we should be able to paperweight to our project here. Still importing it seems. Yeah, there we go, now reload. Should work. Still importing. Thickness, time. Well, it does that. I'm gonna go ahead and create our Gradle properties. If you don't know what this is for, it's good for creating variables in your Gradle stuff. We're gonna take this, we're gonna copy that. Say paper. Okay, my computer is getting a little slow here. Version. I set it to the version that we're going to use. So we're waiting for it to import. It's taking its time. Hello, welcome in. Just setting up a project right now. This will be a short stream, so I'll be going for a little longer. Should have about like 2 hours or so. Okay, but that should finally be imported. Now we can do other variables like version major, version minor, and version patch. We're going to use that to build our version in here. Version minor, version patch. There we go. That's our new version. And now we're going to go in here and we're going to use paper version. Reload Gradle there. Okay, so now we start making our new package. I'm gonna call the main class Limbo plugin. Sends Java plugin. There we go. Get final. Let's do that. Alright. Okay. Private static, so plugin instance, public static, Limbo plugin instance, override, public void, onload, instance equals this. Okay, now, don't need this open, but we're gonna go ahead and copy a little bit of project setup from Bamboo Prison here. We're gonna create a build source folder. And in there, I'm going to create a build.gradle file. And in there, we're going to have just one plugin, Groovy Gradle plugin. Alright. Then, we're going to create src main groovy. Groovy. Go. Obviously in there we're going to create our 2 different Gradle plugins here. and then we're going to copy those as well. Limbo, common, legal. Alright. We can call it .com. Okay, so there we're gonna create. We're gonna basically take all of our common stuff and put it in there in this build.gradle file. Just copy that. So we have our Java ID Java plugin, our Paperwhite user dev plugin, which is where we defined it here. Notice how it doesn't have a version. It's because we only need to define the version in the main build.gradle right here. So we're gonna keep this line. Then we have our group inversion is taking from our main build.gradle file. So our group root project.group is this right here. And then root project.version, same thing. It's this right here from our main build.gradle. Alright, and then we're defining repositories and dependencies. So first, we have our places of paper version. We're defining our common paper version, the one we're going to use for like our base project. And then we also have placeholder API in here because I had that already. I'm gonna actually remove it because I don't think we need it. Then we have the tests. This stuff I'm gonna replace with our current test stuff here. We have, of course, our test block with use JUnit platform there. And we also have another block setting the toolchain language version to 21, to Java 21. All right. So with that out of the way, we can remove this actually, and we can remove this, but we can actually just say limbo.common plugin. We're gonna keep this stuff, and we don't need. See, we have Maven Central. We don't need this. We don't have any dependencies yet, and we don't need that. Should be able to reload, and it should still work. I'm just gonna go down here and copy this process resource. And wait for it to finish loading. Okay. All right. So what this process resources does is it allows us to define, you know, like a property, so like version property, and we're setting it equal to our version up here. And then we look for, we're basically finding the file, our paper plugin.yml, and we're expanding so we're replacing version in the paper plugin.yml with our actual version. So automatically we'll replace the version in there for us when we build. Gonna reload that as well. So now we create a paper plugin.yml. Okay. Now simple paper plugin.yml. We don't need we don't need any of these dependencies. So I'm gonna copy our main stuff here. This obviously is not our stuff. Do window plugin like that. Window version. Keep it like this. That'll be automatically replaced. API version 1.21.11. You can put any website and description you want. These are optional. Tutorial. Limbo plugin. Let's say it. All right. That should be just fine. And we're actually going to need shadow as well, because we're going to be implementing different modules. Take that. So we got Gradle Up Shadow version 9.3.0 is what I'm using at least. There are probably later versions, but it's fine. Then let's say copy this stuff. So what this is saying is when we come over here, tasks, build, assemble, it'll depend on the shadow jar task, which is not yet defined in here because we haven't reloaded Griddle yet. So whenever we run assemble, it'll also shadow jar. Gonna reload that. But we're gonna be using build, not assemble. Build calls assemble though, so it'll all do the same thing. The difference between build and assemble, I actually found out, is assemble just constructs the jar file and compiles it. But build also runs like all the test cases you might define or something like that. So it just does a little bit more. But if you don't have test cases, it doesn't matter. You can do either one. But it might be best to get in the good habit of doing the, proper build, right? Okay, so that's what this assemble that depends on is. It's saying the assemble task depends on the shadow jar task. And then we're also defining some traits for our shadow jar task here. It's saying to set the archive classifier as null, which it does something. I'm gonna be honest, I'm not an expert in all this. I just know these settings from what I've used time and time again. And then this one though I do know. We're setting the name of the output jar file to the name, but we're replacing suffix -dev -all with nothing. So it's we're only gonna produce the one jar file that has all of our dependencies in it. We're not gonna produce two, which it normally would, and then it would produce the one with all of our dependencies in it, or all of our implementations in it, with this name. We'll suffix the jar name with this. And that's the one we would use. But it's a little bit of an ugly name, and we don't need two different jar files because we're never going to use the one without the implementations. So I just replace the one without the implementations with the one with the implementations by changing the name of it. It'll override it. Okay, so that's our build at Gradle setup. We're also going to want NMS stuff here. So I'm going to create another Gradle plugin. Limbo.nms space. Alright, it's basically the same setup, except I'm gonna again take you and replace these with that. There we go. It's basically the same setup, except it doesn't have like paper, because you don't need a specific paper version for that. Because the NMS modules will all have their own different paper versions that they're using. So that's done. We'll use that a little bit later when we create NMS modules. So again, what we're going to be covering today is, basic plugin setup, probably config setup. We'll get some schematic reading eventually, and NMS stuff eventually. I don't know if that'll be in today's stream because again, I don't have much time today, but we'll get there. Okay, this is our basic project setup. If we were to run this, it would work, but it wouldn't do anything because we haven't configured or made the plugin do anything yet. Okay, so what we're gonna do is say, let's see, what are we gonna do next? We want to create let's create a common module. And again, I say this a lot. The reason you want a common module is because you're gonna have multiple different like NMS versions, different modules, and those modules cannot depend on your main SRC module. You can't depend on it because the SRC module will depend on every other module. And if every module depends on SRC and SRC depends on every module, it won't work. It won't build because that's called a circular dependency. And you can't do that because this one depends on this one, but that one also depends on this one. How does it know which order to build the modules in? It doesn't. It'll try to build this one and it'll say, hey, I need this module. So then it'll try to build that module, but it's like, hey, but we need this module. So it'll try to keep building and building, the two different modules, but it won't work because they both depend on each other and none of them will get built, and they'll just say like, oh, you can't build the project. That's why you have to avoid circular dependencies. And a common module is a perfect way to do that. It's not a loophole or anything. Like I've seen many people do, where they would build a module without any dependencies on the other modules, and then use that built jar file as a dependency. You don't want to do that. That's a hassle. That's a waste of time, a waste of effort. It's not good. So you create a common module to get your main class, and then every other module can depend on the common module because this one doesn't depend on any other module. So we're going to set up our build.gradle for our common module now. And that will just follow this example here. So we're going to have our common plugin that we made. Right? Limbo common. We don't need any of these other things here. So you just delete it. Because all that's already configured in this common plugin. So this is as simple as it'll be. We don't have an API module, and I might not create one for this project, so we don't need to add that. We don't need to add this NMS stuff yet, because we're not there yet. So we just created a common module. The next thing you want to do is go to your build.gradle, your main build.gradle, and you want to add that common module to your jar. So I'm going to say implementation project common, and you have to prefix it with the colon, just like that. So now your common project will be built with your jar, and will be put into your jar file, your compile file. Okay, so now that's done. Now we can start creating our common module. First thing we want is something like this class here. It's a simple way to access your main class, anything that's in your main module that you might need outside of it, but wouldn't make sense to put in your common module. So we're going to go make our package as well. I'm going to call this class Limbo instead of Limbo plugin. I don't want them to be named the same thing. That's why I suffix the main class with plugin. Alright, so now we're going to say this class private window, because you don't want to create new instances of it. And then it's just a bunch of static holders, basically. And in fact, that's what we're going to do. We're going to create another class in this called holder, and it's going to hold the instance of our main class and the instance of our common interface that we're going to create as well. So private static class holder, like that. This is going to have a private static volatile Java plugin. I'm not 100% familiar with the volatile keyword, but I know it's kind of needed for this. I'll do a little bit of research for the next stream, and then I'll get back to you on what exactly volatile is useful for. Because I'm gonna be honest, I've never used a volatile outside of this specific use case, like never. So yeah, I'm gonna say that. And then we're gonna want an interface. Actually, this should be public interface common. Right? And then we'll have getters for our configs, and like we don't need a module manager. We'll have a getter for our config that we'll create. Okay, so I'm gonna say then common, like that. Okay, and public static void Java plugin, actually plugin. The get plugin will have we'll just return the holder plugin instance. That. And then we're gonna have a set plugin, but it's not gonna be public. It's gonna be package private. We're gonna say that would set plugin. I'm gonna do what I normally do. You don't have to do what I'm about to do, okay? It's just a habit that I formed. I think it's a good habit. But basically, I like to prefix whatever I can with like final and not null or nullable, you know, wherever it's applicable. So that's what I do a lot. You don't have to do this. It's just something that, you know, I do. Um, so why do I do it? Well, when it comes to methods, um, final on your parameter tells whoever's reading your code that this parameter is not going to be modified in the method. It won't be changed. And also not null is helpful. One, whoever's reading your code will say, okay, so that's a not null variable. You're not supposed to pass null in to this method. And if they do, their IDE will warn them and saying, hey, this is not supposed to be null, right? Like for instance, if I was to say set plugin null here, it's gonna warn me right here. Just say, hey, you're passing null argument into a parameter annotator as not null. And if a developer ignores that, if they're working with your API and they ignore that warning, that's on them. That's their fault. They have to fix it, right? You can't fix it because that's on them. But you could fix it by, if you really wanted to, you could say nullable. And then you could do a null check here. And just return. You could do that. That way, anybody who's using it can say that plugin null. I don't know why they would. It won't do anything. But you can do that if you want. I just like to have not null. And then I like to have the null check outside of this method. So it's just a simple little holder plugin instance equals plugin. And that's it. Right? Okay. And then this also, it shouldn't throw a null pointer exception even if they do pass null in. Because we're not doing anything with it at this moment. Right? But later on the line, later down on in the line, it will throw a null pointer exception if this is null, because we're going to be using this method here. Okay. Let's see. You can also use not null for like right here as a return. That way, if you call this method later, it'll say, hey, you don't need to do a null check on this because it's already guaranteed to return a non-null object. Right? But we're not going to do that for this one because we don't know 100% if this is null or not when we call it. Right? And another thing, we're not gonna call this nullable because that means we're gonna have to do null check every single time, which is a good practice, but it's a lot to deal with, right? If you're using it in your own plugin, which you should be, nobody else really should be touching this. Even if they're hooking into your plugin or your API, they shouldn't be touching any of these get plugin or set plugin methods. So if they're calling it, then they will be responsible for doing null checks. The way that we're going to use it, we're going to know that it's not going to be null, because the first thing we're going to do in our main class is call set plugin. So we know that's not going to be null when we call it. But that's on you to ensure that, right? Okay, so we have nothing in our common yet, but we're also going to create getters and setters for our common. You to pass in common here. Folder common instance equals common. And of course, public static get common. There we go. And we're done. For now. So why do we have an interface here? Why do we have separate getters for get plugin and get common? Why not just have the one interface? Well, it's because sometimes you might need the actual Java plugin deck. And if you're just returning an interface, you're going to have to cast it to a Java plugin, and you don't know 100% if they're passing in a Java plugin as the interface. But for our case, we are going to do that. We're going to say implements Limbo common. Okay, and then inside of our onload, right after we set the instance, this is always going to be, you're going to want this to be your first line in your onload or on enable, always. And then I'm going to say Limbo set plugin this. And of course, Limbo set on. There's our 3 lines of initializers right there. Now, these will not be null. Because these are like this is the first thing we're doing in our plugin. So anything we put after this, these won't return null. Okay. I think I'm explaining a bit too much, but alright, let's see. Let's start creating our config. We're gonna use a simplified version of this system that I created in Bamboo. Because we don't need JSON support. Okay. So we're gonna create it in our common module. That's why I had us create a common module. Because we want to be able to create configs from anywhere in our plugin, not just our main module. Although we don't need to for this plugin. But we are still going to put it there because it's, you know, we will need access to the class anyways if we're going to read from the config in other modules. So that's another reason to put it in the common module, not our main module. I'm just call it configuration. I'm not gonna put it in the utilities. This is meant to be like its own thing. I'm gonna call it YAML config. Right. I'm gonna make it final because we don't want to extend it. We don't need to extend it. I'm gonna say private file. So this will be our actual like file object for our config. Private. I'm going to create a file path variable. Again, you don't need to do final and not null or whatever here. Actually, this one shouldn't be final. And then we're going to have a private file configuration. And file configuration is an object from the, I think it's like snake.yml that Spigot adds to their API and stuff that they implement or whatever. So then we're going to say public YAML config. We're going to say file path. We're actually not going to have, well, actually, so this dot file path feels file path dot ends with dot YML. And if it does, we're going to just set it equal to file path. If it does not, we're going to set it equal to file path plus dot YML. Okay. That's what this little operator is here. So we're saying this dot file path, which is our variable up here, we're setting it equal to one of these two, depending on what this variable is. Right? This is a boolean because ends with returns a boolean. We're saying does it end with .yml? If it does, set it equal to the path because you don't need to append it. But if it does not, then set it equal to file path plus YML plus .yml. Okay, so now we our file path variable is set up. Now we're gonna go down. We're gonna say avoid reload. I'm gonna have a save file and a save config. So save file will save the file to the server if it's not already on the server, and save config will save any changes we made to the file configuration through code to this file on the server. And then reload will do the opposite. It will reload changes made to the file to the file configuration. So all we need to do for that is say, well, I'm gonna make a file getter here. we're going to return new file. And instead of just passing in file path here, because that won't work, that's an absolute path, we're going to return our plugins data folder. So we're going to send limbo dot get plugin, right? We need that, and then get data folder, and we're going to do a comma. We're not going to append file path to it. So what this comma is it's saying that this is the parent file, and then this is the path to the file inside of the parent file. Okay. All right, so now we could say file configuration equals YAML configuration dot load configuration. I'm going to say file, not our file variable. Okay, and then inside of the other ones, we're going to take a peek at this code here. We're going to say we don't need a lot of the stuff, so say file, right? Exists on server, file.exists. Do I even use a file variable here? Yeah, I do. Right. The reload, of course, load configuration, right? Save config is basically just gonna do what I just said. We're gonna import IO exception, and we're just gonna do a e dot print stack trace, even though it warns you not to, because it doesn't like that. It doesn't like you doing print stack trace anymore, but we're just gonna do it for the sake of moving on with the tutorial, right? Right. So this will says if the file configuration is null or file is null, then it's gonna return not save anything. But then it'll try to call save from file configuration. It'll pass in the file from this method here, which is a new file every time you call it. And then if it doesn't work, it'll catch the exception that it throws, and it'll just print the stack trace to the console. Okay. And then this is simply saving the file to the server, right? If file exists, you return, because you don't need to save it, it already exists. Okay, and then you got plugin.save resource. So okay. What we could do is just say limbo get plugin save resource, and then we pass in file path, and you could pass in false here to not replace the file if it's already there, although it's a little redundant because we already checked that ourselves. But just in case, put false in there. Alright, so we're done. We actually don't ever use this file variable. I don't know why I make it, but well, actually we use it right here, but we never set it, so I'm just gonna say I'm gonna delete that. Okay, that's all we need. But we also need to save file and reload config in the constructor here. Save file and then reload. So what this is doing is it's saving the file to the server when you call new YAML config, and it's also reloading the configuration from that file that we just saved to the server to the file configuration right here. And we also need a way to access the file configuration, because again, the file configuration is where you access like get string, get, you know, where you're reading and writing to the config. So we need a way to access that. So what we're gonna do is say public YAML configuration. I'm gonna just call it options, and we're gonna just return file configuration. Actually, it's not YAML configuration; it's file configuration. There we go. And we're done. That's our entire config system for our plugin. We can close that. In our main class, we're gonna create a YAML config variable. I'm gonna call it config YML. In our onload, after all this initial hazard, I'm gonna say config YML equals new YAML config .yml. And you don't need to pass in the .yml there. So with this system, you have to create the config in your resources as well. So we're just gonna go there and say config.yml. And now we can create our config right here. We don't need to create it from code or anything. We can do comments and everything. So I'm gonna say Limbo config. I'm gonna even do a little like that. So we're just gonna set up a couple properties here that we don't really need to set up for this tutorial, but I'm gonna set up anyways. I'm gonna say Limbo world name. I'm just gonna call it Limbo, right? Okay, and I'm gonna go and just say that's all we need. But we can also do a Limbo schematic. I'll say Limbo's skim. That will actually be helpful for us. Okay, so that's all we need. We can actually just replace world name and schematic. Right? We don't need to prefix it with Limbo. That's all we need right there. Okay. So this should now work if we were to build and run it. Okay, so I'm gonna show you how to do that real quick. You just go over to your Gradle menu right here, and then you extend tasks and then build, and you double click build. And it might take a little bit longer on the first run, but see, it already finished there. So good. And then that outputs to this build folder right here that's underneath your main folder. Not under any module. Under the main root, right? I don't know if this music's too loud. I'm just going to turn it down just a little bit. Well, actually... Yeah, let me see. I don't know. Yeah. What do you get? If anyone's in the chat right now, let me know how loud the music is. If it's too loud. Or too quiet, even. Okay, or a little bit for myself. Okay, there we go. I lowered it for myself at least. Okay, so now that it's built, we can go build, and it's in the lids folder. And you can right click that, you can say open in Explorer. And now that opens the folder with the jar file in it. And I'm gonna move that to the same window as my server here. So, you know, tabs. I love that they added tabs to the file explorer. And then I'm gonna go here to my plugins folder. I'm gonna right click and say open a new tab. So we have each folder readily available. I'm gonna copy Limbo, put it in our plugins folder, and then we're gonna run. This should create our plugin folder and our config. Assuming we did everything right. Yep, there we go. See, it's enabled right there. It's under paper plugins because we're creating it with the paper-plugin.yml. And in here, go up, Limbo, config.yml that we just created. And you can see it has our comments and it has our properties there. That's all you need. There is no, with this system, there is no, like updating the config on the server. You're gonna have to do that manually. I used to have a config updater that I used. I think eventually, over time, I just decided not to include it anymore. I'll have to find like a good system for it. One that's hopefully not too complicated or something. But anyway, so yeah, whenever you add a new property in your resources in your IDE, you're just gonna copy it over to the one that's already on your server, or you can delete the one on your server if you're just testing, and then you can have it recreate it automatically for you. And then I'll have all the new properties in it. Okay, so we're gonna go ahead and create like a Limbo world. I'm gonna go Do I want to do it here? I think so. Oh yeah, let's actually, before we do that, we're gonna go to our Limbo. We're gonna grab access to our config. I'm gonna say in the common interface, just simple YAML config get config. I'm gonna prefix it with YAML because there already is a get config method in Java plugin. So we don't want to override that. We want to make sure we're getting the right one. So now it says one related problem. That's because now we have to add it to our main class here. So we just hover over that, implement, okay, and complete turn config YAML. There you go. Now, whenever we call limbo.common or limbo get config YAML, it'll return our config YAML from our main class. Now we're ready to move on. I think I'm gonna create it in our main module for now. Say world. I'm gonna say Limbo world. And I just did this in Bamboo a while back as well, so I know how to do that, right? So we're gonna have these three classes here. We're just gonna create a void world because we don't want to have a bunch of data storing a bunch of chunks and blocks and all that. So void biome provider, void chunk generator, and void world. We could put that all in this one little world. I think I'm just gonna do that. So the biome provider is simply extends biome provider. We're gonna say we can't have this class extended because we also have to extend chunk generator. And actually that's it. So yeah, we can't extend two classes. So we're gonna have to just go here. I'm gonna say private final class. I think it likes to be static. Limbo generator. Then chunk generator. We're gonna have private static class. Limbo biome provider. And by all means, if you don't want to have this stuff in this one class, 100% move it to its own class. You can totally do that. It'll work all the same. So, I mean, this is exactly what I did here. I put them all in their own class, so you can use this as an example as well if you want. Okay, so the biome provider, we don't need to create an instance for it. It's in our class. It's in our same class. So it's going to be, since it's private already, nobody can access these classes outside of this Limbo world class. So with that in mind, we don't need to create a private constructor. We don't need to create an instance. All we need to do is override these two methods here. So we're going to override, I'm going to copy it. All right, so in here, paste those. Import stuff that we need to import, like biome, world info, list. There we go. So what this is doing is saying we're overriding the get biome function or method from biome provider, and the method that we're overriding has these 4 parameters. It has the world info, it has the coordinates of the biome that you are it has the coordinates of the block in order to get the biome from that location. I'm gonna extend this out just a bit so it's not as long. You should have done this in a better order. There you go. We can actually make this the same line. There you go. Okay, so we're not actually going to use any of these parameters at all either. We're just simply returning biome dot the void because we don't need any other biome. And then we're also going to be overriding the get biomes method, which returns a list of biomes in our world. And the only biome we want in our void world is the void. So we're just returning a list phase of the void, and we can actually do selection selections singleton list, and now we know that it's just a list with one item in it. Okay, and then the chunk generator, where you're going to be overriding a couple methods in there too. Specifically, well, quite a few actually. It wants us to do yeah, because we gotta override a couple properties. So I'm actually gonna just yeah, we'll just put it in its own file. Limbo chunk generator. Right, and so we don't need this outside of this package, so I'm gonna remove public from it. And we're also gonna make it final. Okay. So we're gonna be overriding and again, we don't need an instance because we're only ever going to be creating one world, but I suppose it would be good to not have to create multiple of these providers and chunk generators, because the worlds are all going to use the same one. So I actually might do that. I'm going to say instance. Look at that. So we're not doing a get instance method. Well, I mean, we are actually. Well, actually, we don't. Yeah, we don't need it. We can make this public because it's final. There you go. So we could just say limbo biome provider dot instance, because it's public, but also because it's final, people can't override it. Of course, without reflection. So now we can actually say limbo. Now you can't create a new instance of it outside of this class. Okay. Same thing here. Public static. Annotate and stuff. So you do actually want to make these two instance variables final, by the way. And okay, so now we have quite a few methods to override. Of course, we want to override. And I'm just going to copy these. A lot of typing. Okay, of course, you gotta import everything. Just import all this stuff. Location, yep. Biome provider. And Limbo. Okay. Go. Make it package private instead of private. That way this one can access it. And by package private, it means any class in the same package can access it, but outside of that package, it can't. There's our biome provider. Here's all of our overrides. So let's go over this, right? So we have a method. It's called get fixed spawn location. You pass in the world, and you pass in a random, or rather they do, and you're just overriding it. But we're not going to use the random because we want a fixed spawn location. And what we're going to do is we're just going to return a new location with the world, and we're going to pass in x as 0, y as 64, z as 0, yaw and pitch also as 0. So it's returning the spawn point of the world. Alright, and then we're overriding a couple properties. So should generate noise, you say false. That way it's faster to create the world. And there's also another method, should generate noise, but it passes in the world info, passes in a random, passes in the chunk coordinates as well, chunk X and chunk Z. And we're also just going to return false. We're not going to use any of these parameters. Should generate surface, we're going to say false. Generate surface again, but with parameters, we're going to also just return false. Should generate caves, no, we don't want that. Again, should generate caves, also return false. So if you don't want to type all these methods out, by the way, I'll show you just a second how to just quickly override them. Should generate decorations, we're going to say false. Should generate decorations again with parameters, we're going to say return false. Should generate mobs, false. Should generate mobs with parameters, again, return false. Should generate structures, false, and then of course another should generate structures, also going to return false. We want a clean slate of a world. We want nothing in it. There we go. There's our methods that we're going to override. So to override them easily, just go over here, right click on the class you're extending, chunk generator, say generate, or you can click Alt Insert when you're hovering over it. And you're going to click override methods or Control O, which you can actually just do from here. You can click on that, you can say Control O, it'll pop up this menu, and you want to just click on the ones you want to override, and you can Control click to select multiple. You can Shift click, etc. Click all of them, whatever. And you click OK after you selected them, and then it'll automatically generate all this code down here. Just make sure that you're returning the stuff that we want to return. Everything is false, except for the location, get fixed spawn, and the biome provider. Okay. And that's it for our chunk generator. So in our world now, we're just going to create a static create method for it. Right. It's going to return world, of course, and it says nullable. Let's assume that something could go wrong during creation. And we pass in the name of the world. So final string world name. Okay. So now we're going to get a world creator. Okay, sorry about that. I don't know what I'm gonna do with this kid. He just came in saying he's hungry again. He just ate pizza. I don't. I can only make so many lunches for him, man. Anyways, world creator, new world creator. Right? We pass in the name of the world. Just passed in as a parameter. And then we also want to say generator. I'm going to pass in the instance of our chunk generator. So, load chunk generator dot instance. And the reason we could do this, by the way, we're setting a world creator equal to a new world creator dot generator, is because generator also returns world creator. Okay? That's the only reason we're allowed to chain it like this. That implies that world creator is a builder of some kind, right? New world creator, right? It has all these different things, and then the generator, of course. Generator. It returns a world creator, but it returns this after it sets the generator, right? Pretty simple stuff. So if you ever want to create a builder, It allows you to just chain methods like this to define properties for it. That's how you would do it. You would just say like, oh, create the class, right? And have a method that returns the class that you're in, and then return this, return that instance of the object that you're modifying. Yeah, that's our world creator. Then we're gonna create a world from it. I'm gonna say final world equals bucket dot create world, and we're gonna pass in our world creator. Right, because the world creator has the definitions of the world for us. And then we're gonna say we're gonna return world. And the thing is, this world can return null. As you can see, you hover over create world by bucket, and it returns nullable. That's why I also return nullable here. I don't want to have to handle what happens if the world is null here. I want to handle that elsewhere, outside of the create method. Right, and then we're gonna do a couple things to the world if it's not null. So if world not null, first thing we're gonna do is we're gonna set a real block at the spawn point. That way, if you visit it, you'll have a block to stand on. But that'll be it. And we're also gonna set the game rule locator bar to false. Set game rule dot locator bar. And actually, it wants a actually deprecated. Renamed to game rules locator bar. That's why it wants you to use game rules, not the game rule. And we're gonna set that game rule to false. That way the locator bar is not enabled. Okay. And then we're gonna set block data, not block, but block data. There actually is no set block method in world AC. Set block data, and then we're gonna say world get spawn location, because that should return our fixed spawn point that we created in the chunk generator, or the I think there was a chunk generator. So we got spawn location, and we're gonna actually subtract 1 on the y. So we're gonna say dot subtract 0, 1, 0. So we're not subtracting anything from z or x. We're only subtracting 1 from y. And then the next thing we're passing in is bedrock, but we have to create the block data for it. So bucket create block data, we pass in bedrock, create bedrock block data. And so that will set a bedrock block right below us at the spawn point. Okay. Now we have our Limbo world created. We can go here. I believe how we generate it is simply calling new on it, because it already says bucket create world. I'm gonna go down to our main class here and just check, right? There's a lot of stuff here. The on enable. I believe I created in the private minds module actually, but that's fine. We'll just create it in here because we don't have other modules. So override, I'm going to create an on enable now. There you go. Limbo world create, and we're going to pass in our configs, our configured world name. Config white now options get string world dash name. I'm going to default it to limbo, so we can't pass null in there. So what this is saying is we're going to call the create method that we just created, and then we're going to pass in the world name from our config. So right here, it's getting world dash name, right? Get string world dash name. So it'll return limbo. But if for any reason config doesn't have world dash name defined in it, it'll return Limbo here as a default. Right? And that's what we were doing in our config class. We have the options, which returns a file configuration that you can call get string from. So that's what we're doing there. So this should work just like this, I believe. I'm going to build it. Done building. Now we can see how quick this is. Copy. Let me actually open the plugins folder again. So we have plugins and Limbo. And simply delete and paste. So now we have our updated version in our server. And we run. And we should see the Limbo world being created. Which shouldn't take any time at all because there's no blocks in the world. Here we have our Limbo world. So I was to go in and let me make sure I don't have like a server IP being shown here. Just delete it. I do have one server on this instance of the game, but anyway, so join localhost. And we're actually gonna, as soon as we get in there, I'm gonna say a couple of things. So this is the first time we joined it, right? So we're gonna say whitelist enable or whitelist on. Whitelist add myself and then opt myself. There you go. All set up. We don't want someone somehow joining the server, even though I don't have it put forwarded, I don't believe. There we go. We should be able to do. Let me actually. Spawn mob. They changed all the game rules. Got all the mobs here. Okay. I should be able to do world on Limbo. Teleport to it. And okay. It seems I didn't spawn at 0, 0. 0, 64, 0. But the block did spawn in. This is our void world. We're going to use this as a base for our paste our schematic around this block here. Right, so there we go. That's our current progress. Now we can stop the server because we don't need to test anything else. Okay. So schematic loading. How do we want to do this, right? Let's actually go back into the server real quick and make a little schematic we can use to load. Whenever the server starts back up. It doesn't take too long, but you know, you do have to have a tad bit of patience. If you don't got patience, I feel sorry that you're trying to be a developer. I'm just being real. Because there will be times when you're running into a lot of issues that you gotta deal with bugs and stuff. Okay, we're gonna create a schematic. I'm gonna actually go to overworld here. Yeah, so I'm gonna blame the world command for putting us in the random spots. It's because we're not changing our coordinates. We're only changing the world that we're in. It's keeping our coordinates the same. That's why we teleported away from the spawn block. Okay, so I'm gonna go up 100 here, and I'm just gonna create a little, nice little box. I don't know. And go 1, 2, 3, 4, 2, 3, 4. Go ahead and copy, select our positions. Bedrock, enter, beacon. we'll place a bedrock underneath that. Okay. And then we can create, like, we create any schematic we want, really. You can even find a schematic online to use. But if you do that, you will want to ensure that it's the specific schematic version that we're gonna utilize. There's our little box, right? I'm just gonna click that. Copy that. And I'm gonna go right in the center here. Just like that. And ensure that we're in the center of the block by doing this TP post command from Essentials. And I'm gonna say copy. I'm gonna not copy air. I'm gonna count better up to be sure. 161, but we copied yeah. We have a beacon in there as well. 162 blocks only. We didn't copy any air. Schematic save. I'm just gonna call it Limbo. So this was what Fastest World that it does. They have different schematic formats you can save the schematic as, but the default is Sponge version 3. So we're gonna use Sponge version 3 to load our schematic. So we have that schematic saved now. We don't need to be in the world anymore on the server. That saves to our plugins and Fastest World Edit schematics right there. We're gonna leave that there for now. What we want to do is say, go here, go to our common module, and we'll create a schematics package. All right. How should we do this? Should we start with the schematic loading? I think so. I think it'll be fine. I'm gonna copy what I did here, right? Because I already have it done, and it's a little bit takes a little time to write this. So let's see. So we have 3 different classes. We have a file schematic loader, and we have a schematic loader. So I'm gonna let you guys. I'm gonna show you guys how to do different schematic loaders in case you want to. Of course, we want a interface schematic loader, right? And this will have our load method, which is just a void method, doesn't return anything. Say void load. We gotta pass in the path to the file. So not null path to the file, right? And it's gonna throw an IO exception. There we go. There's our interface. It's the only thing we need. We're gonna go and say, I'm just gonna call it Sponge v3. Sponge v3 schematic loader. Okay, because it's not specific to files, it's just a specific format of schematic that we're going to be loading. So this is going to implement schematic loader. This will have our load method there. Okay. So now if you want to use different schematic loaders, we're going to create a schematic manager here as well. Is final, as well as our Sponge v3 schematic. We can make that final, and also we're gonna move it actually to another folder called impl, which stands for implementation. So the Sponge v3 is an implementation of schematic loader. That's why we're putting in an implementation folder. Okay. Our manager will handle creating which loader to use, and also will handle what happens when we reload the plugin, load the plugin, check which schematics are created, stuff, or loaded. So we need a, let me actually just pull this to the side. Write this from scratch with the reference. So we're gonna say, it's gonna be a singleton. And a singleton means you can only create one instance of it at a time. instead of having multiple schematic managers, you only want one. Just like your main class, you're never going to call new on your main class. Sorry, my headphones cable is getting in the way of my keyboard. Okay. So it's static. I'm gonna say this one's not null. If it's null, we're gonna create a new one. If instanced null. And I wanna get instance. There we go. If instance is null, then instance is new schematic manager. And return instance. The second time you call it, this will only be ran the first time you call get instance, right? This setting it if it's null. Every other time you call it, it won't be null. Alright. And then we're gonna say private schematic manager. Because it's gonna be a private constructor. Okay. And then we want the folder. This folder will be the folder for where we put our schematics. So, folder, new file, we want limbo dot git plugin data folder schematics. No file extension because it's a folder. Okay. And we're gonna create a string set of schematics, and this will just hold our IDs. I'm gonna set that to a new hash set. You could, if you really wanted to, could set this up here. You know, it makes no difference. It literally does the same thing. I just like to be a little more organized and keep it in the constructor. This is how I do it. Doesn't really matter. It's up to you guys. So, yeah, and then we want, of course, our schematic loader. Private schematic loader. Let's call it loader, right? So our loader, let's say new sponge v3 schematic loader. And you can set up like a simple, like you could pass in a string here for the schematic loader, and then you can say like if schematic loader equals sponge v3, and then set loader equals sponge v3. But we only have one, and I'm not going to implement other ones. We're just going to use the one. And now we're going to say, we're going to create a reload method. I'm going to call onReload just so it's in the same naming convention as the main class, you know, on enable, on disable, on load, etc. So do onReload, right? And in the onReload, we're going to say schematics.clear. We're going to clear all of our loaded schematics, right? If schematics, folder exists. If this folder does not exist, we're going to say folder.mkdirs, which stands for make directories. It will make the folder, and it will make any parent folder that it doesn't, you know, that's not created, but they should be, because we're going to call this after we create our config, which creates our plugin folder, which creates, you know. So this will only really create the folder the first time your plugin is initialized, unless you delete the folder. Now we're going to say try. We're going to say stream path. So we're going to try creating a new stream. I'm going to call the variable stream. Say files.list folder to path. And that's it actually. So what we're doing here is a stream is an auto closable. And what that means is if it's closable, it means you have to close it when you're done using it. But since we're putting it in this try, you know, this try statement, kind of like an if statement, we're putting it inside the try statement and we're defining a variable for it. So outside, when we're done with the try block, it will automatically close the stream for us. So we don't have to call it, like, we don't have to say stream.close. It will automatically close for us if it ever opens in the first place. And this is where we're going to catch an IO exception here. And I'm going to print the IO exception stack trace there. So There you go. And then with the stream, we're gonna filter out any file that doesn't end with .schem. So p2string ends with .schem, right? So now, what this is saying, we have now still have a stream of file paths, except we're filtering out any file path that doesn't end with .schem, right? As this is doing. And this is a lambda expression. We're creating a variable here called p to represent the path that we're currently iterating on. Think of it like a loop or a for each. Speaking of for each, we're going to, now that we have a stream of files that are definitely a .schematic file, we're going to call for each on the stream. And then we're going to say this load. We don't have a load method yet, but we will here. Public void load pass in the path. I'm loading a specific schematic here. So now notice this error went away. It's calling load down here for every file path in this stream that ends with .schem. That's what we're doing there. I hope I explained that well. I should preface, I'm not the best teacher by any means. So, but if you guys have any questions and you're watching live, feel free to put them in the chat. Or if you're watching afterwards, feel free to put them in the comments. I'll try to address them in the next stream or reply to it if we're done with the series. So we have our load method. So what are we going to do in the load method? We're going to load the schematic. So I'm going to say final. We're going to get the ID of the schematic. And I actually have a file utils class to strip an extension from the path, but that's fine. We can just do it here. Path toString. I'm going to say substring 0 path dot lang size no path toString lang. There we go. And minus, say, like 4. Hold on. 6. I'll explain in a second. I'm getting a phone call. Okay, sorry about that. So, what we're doing here is we are removing the extension from the file name. Extensions are always at the end of the file name, right? So, first off, we're filtering for, .schem files. So we know down here that it's going to be a .schem file. At least if it's called from on reload. We can actually make this private to ensure that, because I doubt we're going to be loading schematics manually later on. And what we're doing here is we're saying we're setting ID equal to the schematic file name without the extension. We're saying path toString.substring, which returns a string like after 0 characters and before this amount of characters. So it'll start at the very first character if you pass 0 in as the first parameter here. And then it's essentially going to loop through and append each character of the file name until it reaches this index, which is the length of the file name. So you're going to the end of the file name, and then you're subtracting 6 characters. So right here, 1, 2, 3, 4, 5, 6. So you're subtracting this from the end of the file name. And you could also do a path.toString.replace.schem with an empty string. You could do that. But I think this is just, you know, a little more, you know, whatever. Because I don't know. You could do that if you wanted to. Essentially, that would look like this. Path to string that replace dot m with nothing. You could do that if you really want to do, but I'm gonna stick with the substring. Okay. And then we're gonna say try. We're gonna get our loader. I'm gonna load in the path, not the ID, but the path, right? I'm gonna catch an IO exception. Since this is just a small line, I like to collapse it onto itself. And then E print stat trace. I'm going to return, well, if there's an exception. We can actually move this down, so we're not doing that operation if it fails to load it. And then we're going to add the schematics. We're going to add the ID to the schematics set that we created up above. Okay? And then the set, right now, it's not storing any schematic information. All it's doing is storing the ID of the loaded schematics. And that's simply so that we can check quickly and efficiently if the schematic's loaded or not. So we're going to say public boolean is this. We're going to pass in a schematic ID to check if it exists. And all we're going to do is we're going to return if the schematics set contains that ID. Right? And we're actually set it to 2 lowercase. And same thing up here, we're going to say 2 lowercase. Actually, we can just set right here 2 lowercase. There we go. So that way we don't have to worry about case sensitivity. And they're all the IDs will be lowercase. And we don't have to worry about case sensitivity when we're passing into the parameter. It'll automatically lowercase it for us. All right. And then now we can also say public set string get IDs, and you can return set copy of schematics. You don't want to return the schematic set by itself, otherwise people can modify it by calling get IDs. You don't want that. What you would rather do, you want to copy it. That way they can't modify your set that you have in the schematic manager. And we're done with the schematic manager. For now. We might have to come back to this later after we get some NMS stuff set up. Okay, so the sponge schematic loader now. Go ahead and start working on that. Before we do though, let me explain a little something. Why is it not letting me go back? There we go. Okay, so let me explain a little something here. We're essentially going to be reading the schematic file manually. And what that means is reading through every byte in the file. That's a lot of information to loop through, but that's fine. What we want to do, we want to make sure we get all the information. So an NBT compound is used to help us read through it. And so the NBT compound has stuff like get short, get, other data and stuff. Like get int array. It's essentially, think about it like a config system, like file configuration. You know how file configuration, the config, you can say like get string or get boolean, whatever. Think about it exactly like that. It's just a system that allows us to read through the file and get a specific object back. There's other compounds and stuff. So Paper actually has their own NBT compounds and everything, and they work fine for smaller schematics, like the one that we just created in our server. Right, that would work totally fine with Paper's NBT compounds. But if you ever want a bigger schematic, it will fail. It will not read it. It will be too much information for it to handle. Paper actually put a limit on how much it can read at a time. So I suppose you could probably split it up in batches, but that would make it take longer to load. That would mean your server would take a little longer to start up, and that's not very fun. So what we're going to do is we're going to actually create our own NBT compound, which is why I have this NBT thing here. we're gonna basically create our own MBT system and reader. That way we can read schematic files that are larger than paper would allow us to. This is exactly what I did for Bamboo. Obviously, this is Bamboo Prism. And that's the only reason the server doesn't, the server can even read the big schematic that I have in my private mine. Let me pull up the example video that I've shown. So I believe I'll just pull up Showcase 5. I believe it's Showcase here. Let's see. Okay, yep. So, we're basically going to be doing the same thing that I'm doing in my prison core. This is just a public video I have on my videos, you know. You join the server, and you spawn. If you spawn in the private mines world, it automatically loads this schematic around you. These are all fake blocks. You can see how it's loading, right? So it loads, and then bam, right? This schematic is absolutely huge. I tried it with the papers and BT stuff. It didn't want to load it. And then it also took forever to send to the player and all that. But with our own NPT compound, it's pretty much instant. So that's what we're going to basically be doing. And I'll show you how to do that. Just get this set back up over there. Okay. So we're going to be doing that before we start with the loader, because we're going to have to use that in the loader. So let me, again, pull this over to the side, and I'll use this as a reference. Let's see. Up. NBT. Alright. We have schematics, it's fine, that's all good, and then we're going to go down and we're going to create an NBT package just to keep our project organized, right? So NBT compound, and this will have, this is not going to extend anything, but we're going to have a map. So, a map of strings and objects, and this is just like JSON. JSON, at least when I implement JSON in my prison core, I use a map string objects to load the data into, and then we read from the map whenever we get something. So yeah, we're going to say NBT compound, and we're going to pass in a map again. This is this.map equals map. We're not going to copy it or anything. Alright, and then now we're just going to create a simple little structure to, you know, get stuff from it. I'm going to say boolean has. And we're going to, you know, pass in the key to check if it has it. And simply map contains key. Okay, and then we're going to create a method to get the key set of keys in the map. Which is, again, obviously a set of strings, because our key in the map is a string. Let's say return map.keyset. Okay. And then, again, we're not creating a copy of it to return, because we want to be able to modify the map. Because the NBT compound itself is supposed to be modifiable. Or at least readable. Anyways, and it would take a lot longer to read if we create a copy of everything. Well, we're gonna get compound, and we're gonna essentially get an NBT compound from the map, because, you know, you can have NBT compounds inside of NBT compounds. That's what we're gonna do here. We're gonna say object, and return map get key. So we're going to say if O is an instance of NBT compound, I'm actually going to make this, I'm going to do a better practice here, just to reinforce that you guys should always follow good coding habits. That's not what it was. There we go. So we're gonna return, we're gonna do another one of those operators, right? Otherwise null. And this is meant to be nullable. Okay. So what we're doing here, we're saying we're getting the object from the map, because we have a map of objects attached to string keys. So we're getting the object at that key. And then we're going to say, we're going to return if the object is an MBT compound, then return the compound. And we're also defining a variable for the compound instance. So it's casting it for us. This is called like a pattern variable. All right, and then if it is a compound, then return the compound that it is. Otherwise, return null. That's it. If it's not a compound, then return null. Don't cast it or anything. Don't try to do anything with it. Just return null. And then why are we not null checking? You might be asking if you're astute. Well, the instance of checks for us if it's null. If it's null, it can't be an instance of MBT compound. So we don't have to worry about checking null manually. It already does that, the instance of check. All right, so there we go. We got our get compound to get a compound from the map. We're also going to want, I'm going to create another method. MBT compound. I'm going to say get compound or else, right? We're going to pass in the key again, and we're going to pass in a compound to return. Actually, I lied. Wait. I lied. We're not else. Self. Get compound or self. What we're gonna do is say we're gonna get MBT compound, and we're gonna call it other. So we're trying to get another compound at the key that we pass in. And then we're gonna say if other is null, then return this compound, or return other if it is not null. So we're returning either the compound that we're calling get compound or self from, or we're returning the compound that it got from the key, right? Then I'm gonna make another one. Get compound or throw, right? I'm gonna say final not null string key, and I'm gonna say final not null string throwable message. So what we're gonna do now is say we're also gonna have it throw an illegal state exception for us. Right. If you're wondering why I'm on multiple lines here, this is what it would normally look like if you don't have multiple lines. But since it's such a long line here, you don't want to ever have to have the horizontal scroll bar down here. If you do that, then you're doing something wrong in your clean code. You want to keep it clean. You want to keep it readable. You don't want to have to scroll horizontally. So that's why I split up the parameters onto multiple lines if the method is getting too long. If the method signature, is getting too long. And then sometimes I like to do that as well. So I'll keep it like this for now. So we have our parameters, and we have what it might throw. So in here, we're going to say MBT compound other equals get compound at the key we're passing. If other is null, then we're going to throw an illegal state exception. And we're going to pass in the throwable message. I'm going to throw a new illegal state exception. There we go. Otherwise, return other. There you go. These are just some helper methods right now. And now we're going to have our methods to like get a string, get short, all that stuff. Get different data types. I'm going to collapse these as well. I'm gonna do a little trick here. Region compound getters. I'm gonna go down here and I'm gonna say named region. And that allows me to collapse that entire block of code right there. Very helpful if you want to have a little bit of organization inside your IDE. I'm gonna put spacers there. There we go. And now I'm gonna make another region. Call it data type getters, I suppose. And I'm gonna end region as well. Okay. And now I'm gonna say public nullable string, int string, at the specific key. Final object equals map get key. And then I'm gonna say return instance object instance of string and return the string, otherwise return null. Okay, it's the same thing we did for the normal get compound. Public nullable short, not the primitive, but the object short. Get short. The key as well. Map get key. We're gonna have a lot of map get keys in here, by the way. So if object instance of short, name it something else, then return short, right? Otherwise, you say return object instance of number. Then we're gonna return number dot short value. Otherwise, we're gonna return no. So we're doing two instance objects here, not just the one that we do for the string and the compound. Because we could say get short and then oh, it's not a short, but oh, it's a number, which could be a short or an integer or a double or whatever. And then we're calling the return short value, so it's converting it to a short. It's converting whatever the number is to a short for us. Right. I'm going to do the same thing for integer. Click nullable integer get integer b. Final object app get b. If object instance of integer, otherwise return object instance of number int value or null. There we go. Now we have actually we don't have any other types to return besides byte array and an int array. So public byte, the primitive, so we don't have, it can't be null. Well, it can, but I can't really annotate not null or whatever. The get byte array. Go. Again, final object map get b. All right. Return object instance of byte array. Then return the byte array. Otherwise, return null. That should work. Public int get int array. Again, we're doing the same thing except for integers, not bytes. Object. You can see the pattern here, right? Instead of int or no. And there we go. We're done with the MBT compound, but there are two other classes. There's a tag type, which is just an enum. So we're gonna create that. Pretty simple stuff. If you don't know what an enum is, basically, well, you'll see. I'm gonna call it tag type. So we have, basically, we're gonna be reading through the file, right? It's an MBT, it's a file full of MBT data. I guess there's different tags for them, right? So you have end, which is 0, So we're going to define our enum values right here. We're going to stop it at a semicolon, and then we're going to have an ID for each one, a byte ID, right? And then to initialize that, we're going to create a constructor for our tag type. We're going to pass in an integer ID, and we say this dot ID equals, pass it to a byte ID. Okay. And now, see this is red, we have to pass in a variable now. So we have end, we have byte, which is b1, we have short, which will be 2, we have int, which will be 3, long is 4, float is 5, double is 6, byte array 7, string will be 8, list will be 9, compound for MET compound will be 10, int array will be 11, and a long array will be 12. There we go. Now we have different data types corresponding to different IDs that we can check easily. So now we can come down here and say static null tag type from ID final byte ID, passing the ID that we're going to check. We say throws IO exception as well. Now we're going to loop through our tag types that we just created. We say final tag type. To loop through an enum, you simply say tag type dot values. Right. So now we have a loop. I think it's an enhanced for loop because you just have the colon here. You're saying you don't have to say how it iterates. It knows how to iterate from this. Simply saying you're finding a variable for the current tag type that you're on, and then you're saying, hey, for every value, whatever, my control key wasn't working. It's because my earbud wire was underneath it, preventing it from being pressed. Anyways, so you're gonna say if tag type dot ID is equal to the ID we passed in, and return that tag type. Otherwise, we'll throw a new IO exception. We'll say invalid tag ID plus ID. That's why it's not null, because we're not returning null. We're throwing an exception, which will inherently prevent the other code from running that calls from ID. Right? And this is non-public package private. And we're going to say public byte. I went way too far out of scope. Public byte get ID or an ID. Not we want the primitive, not the object. This is our tag type. And then we're going to create another one, which is a how to use the tag types. I'm gonna go here and I'm gonna say, I just called my MBT system simple MBT because it is pretty simple. Final class, and it's actually a static helper class, like a utility class. So I'm gonna make it private constructor so it can't create an instance of it, because we don't need to create an instance of a class that only has static methods. That's why we deny people from creating a new instance of it. It's just a waste of memory. We're going to create a method here that will return MBT compound that we made. As you can see, there are there's MBT component from adventure, MBT component builder. That's not what we're doing now. I think that's different than MBT compound stuff. And we're going to say read. We're pass in an input stream. Yeah, we're going to pass in the input stream, and we're going to throw an IO exception. We're unable to read the input stream. So I'm going to create a new data input stream. I actually called this one raw in, so it's just, you know, the raw input stream, and then the data input stream I called it in. and then we pass in not the input stream, but a new buffer input stream. We pass the raw input stream into the new buffered input stream. And then now we have a data stream that we can actually read from. So byte, we say root type in read byte. So we're reading the byte from it, right? You can read other things from it, but we're just gonna read the byte. And make that final, I believe. Yep, and then if root type not equal tag type dot compound dot id, I'm gonna throw a new IO exception. Root tag must be a compound dot. Instead, we got root. Yeah. And we're gonna say in read UTF. And we're gonna return read compound payload, which is gonna be another method that we'll create. Okay. So we're gonna say private static, gonna be private method, MED compound, read compound payload. Gonna create this so we have it. Not null data input stream. There we go. That's our method. It also throws a IO exception, of course. There we go. And this, we also have another method here, private static, BT compound, read gzipped. And this is, I believe gzipped is another type of zip format. I don't actually know if I use this in my Bamboo Prism implementation, but we'll find out since I'm copying it, right? Rows, okay. So it's basically, instead of read, we'll use read gzipped if it's a gzipped schematic file. Gzip input stream. It's nice that it just already has it, right? And we don't need anything else. We're just passing the raw in. I'm just gonna return read gzip. So we're calling read anyways. And this, again, this is auto closable. That's why it's in a try statement. As a parameter type thing, you're defining the variable, because you can close it after it's done. So essentially it's saying return read, and then when read does its read compound, and then this returns, and then this returns, and then this returns, it'll finally close it automatically when it's done. Okay. Alright. That's done. Alright, now we can move to the read compound payload, which is essentially reading the contents of that MET compound. We're going to create a new map. String object, and this is what we're going to pass into the MET compound when we create it. Wish it would just let me import it like that. I gotta move my mouse all the way over and hover over to import. Map. Gonna be just a new hash map. We're gonna say while true. We're doing a while loop that'll loop forever until we break out of it ourselves manually. Byte type ID. We're gonna say in.readByte. Right. We make that final. If type ID equals tag type dot end, which means the end of the file. We're gonna break out of the loop because we hit the end of the file and it's not enough to read. Okay, name read UTF, which is essentially reading a string. So I made it a string variable. Value read payload type ID read payload will be another method that we'll create shortly. And map put name value. And then we're going to return new MBT compound with the map that we just created. There we go. Now let's go ahead and read payload essentially. First, we're going to create a helper method that'll automatically throw an exception for us when we call it. You're saying negative byte array length. Length. Rows IO exception. This is literally all it's going to do. Throw new IO exception. Negative byte array length. And passing length is why not. Alright, so that'll be used in our read payload method. Just so we don't have to type out throw new IO exception every time we call it. Or every time we need to throw it. So another, again, private static, not null, return an object. So we're returning the value at the key, at that name, essentially. Also, by the way, whenever you call read, essentially what happens is, of course, we're reading through the file, right? But there's a cursor in the file. You know how you have a cursor right here? So imagine we're reading through this file, right? This is the cursor right here. Ignore my actual cursor. Alright, so this is my cursor right here. It starts at the beginning of the file. And then once we call read, it'll move the cursor by 1. So every time you call read UTF or read byte or whatever, it'll move the cursor by 1 forward. So that's why we can say while true and keep moving the cursor forward as you're reading through the file as we're looping through it. And that's why when it hits the end of the file, right? This is the end right here. Type ID will be end, and it'll break out. Nothing else to read. Just letting you know that. Because there will be times where we'll have to skip over a line or a character, and so we'll just call read UTF for no reason, like right here. Calling read UTF, and we're not setting it equal to anything. Or we're not setting anything equal to it. We're skipping this character. Or that value. Because we don't need it. It all depends on the schematic format as well. Which is why I have this this page open from when I was working on Bamboo. Sponge schematic specification. You can find it at github.com/spongepowered/schematic-specification. That's the repository for it, and then it's under the versions folder, schematic-3.markdown. So this is laying out the entire format of the file, and this is how we figure out how to read the file. So again, we're in version 3. It has definitions here. You can find out like what a MBT is, what a block state is, what a block entity is, what an entity type, entity, biome, etc. Because all of that stuff is stored in the file, the schematic file. And there's different data types: integer, short, byte, long, float, double, unsigned, short, integer, array, bar int array, all this stuff. So specification. Here's how the file is laid out. This is how the schematic file is laid out, and it's in JSON format, right? Unless you look into the .schem file manually, it's a whole bunch of like MBT data that you can't read. But this is how it's laid out. So imagine it's a JSON file that we're reading through. It's just encoded into NBT stuff. Realistically, so it starts with a empty root parent key, right? So you skip over that, which is what we were doing, and then there's a schematic, or we were skipping over this. Either way. So now we want to loop through the schematic part, and in the schematic part, see all this dot right here. Bunch of different information in this little schematic block right here, and that includes like the version just 3. It includes a data version, which is, you know, like Minecraft data version. There's metadata, there's width, height, and length of the schematic. There's an offset from where you copy the schematic from. Then there's the blocks, right? The blocks is a container of blocks, which is another data type that we'll have to figure out how to read, right? And then same thing with biomes and entities. That's how it's laid out. So again, schematic, version, data version, metadata, width, height, length, all that stuff. It's in this order, pretty much. So that's what we're reading through. We're trying to read through. All right. So in our read payload method, we want to pass in the ID of the type, the tag type. And I'll pass in the data input stream that we're currently reading through. We're going to get the tag type from the ID. Tag type from ID. Type ID. That we created a method for this. And again, we need to make sure that this actually throws an IO exception. That way we don't have to catch the from ID. It'll be caught in the, it's already caught, or it'll be caught in the loader, not in the, this class, because they all throw IO exception. Alright, so now that we have the tag type, we're gonna do a little return switch statement. So if it's end, if the tag type is end, then we're going to throw a new IO exception. Unexpected end tag payload read. So it's essentially saying that we got an unexpected end tag while we're reading the file. And we're saying payload read to specify that it's in the payload, the read payload method. Okay. And then we have another case, we have byte. If it's a byte tag type, then we simply say in read byte. And it's automatically returning the in read byte. We have short case, read short, case int, read int, case long, read long, case float, float. Okay, and then case double, read double, string, in read UTF. Okay, case compound, and then we're gonna, instead of in.read, because there is no in read compound, right? Say read compound payload, and then we're gonna pass into it. And that'll basically, it's called recursion. If we find another compound, which essentially is the block container. Blocks is a compound of whatever's in block container. So click on block container to go there. Doesn't want to take me there. Right. There is a, where did it go? Block container that has, yeah, powered object. So the block container is like the way this. It's a map. You have air and how much air you have. You have blanks, the variant of blank, and then how many of that. And then you can even have custom blocks in it. Oh my goodness. Oh my god. Alright, people just got home and they're screaming for no reason. Okay, anyways, so compound, so we're recursing through our own static class here. If we find a compound, we want to read that compound, which we are already doing. We're already reading through a compound, but we want to read through the compound that's in it. And when it's done reading through that compound, it'll return here, and return here, and then it'll go up the stack. Alright, and then if it's a case of a byte array, we actually have to do a couple of special things here. We say we're gonna make a body for this. Get the length of the array. Whenever they do an array, it's always going to have the length of the array before the actual array. So you got to read the length of the array. Otherwise, you won't know how to loop through the array because you won't know how much is in the array, right? You have to have that information whenever you're encoding something, like the length of a list or an array. So if length is less than 0, then we're going to throw that negative byte array error. Now we're going to create a new byte array of length. And then we're going to say in read fully array. And a yield array. Right. That's done. So this is how you read like a byte array or an array. So read fully will populate our array with whatever it's reading, right? And then we have the same thing for list, pretty much. Byte, element, type ID, byte. So we're actually getting the type of what is in the list, so the type of object in the list. And then we're reading the length. That's how they structured it. I believe, let me see that if they show that on the in their document here. I don't think so. Okay. Yeah, no, they don't specify that, but we know that the it has to be a list of something, right? So we're getting the byte that specifies what it is, and that's why we have the tag type. By the way, this order means something. If the element type ID is 1, then we know that it's a list of bytes. Basically, is what we're doing. And then again, we're reading the length of the list so that we know how to loop through it. Then negative byte array length. Again, if the length is 0 or less than 0. Otherwise, we're going to say final list of objects out new array list. Out just means we're outputting it. So then we're going to loop through the data. So it's out, add, and we're going to say read payload element type ID in. So once again, we're recursing, but we're not recursing through our read compound payload, we're recursing through our read payload, which we're currently in. So we could read the proper object that's in the list. And then we're going to yield out. Not 100% sure on the specification of like what yield means exactly, but I know that it's for like this use case here. It's for like a return switch. Okay, now we have the same thing. We have an int array. And again, this is why we had the negative byte array method that we made that just throws the exception for us, because we're looping through so many arrays and lists that we don't want to have to retype throw new exception message, you know. We just want to have to call this one method that does it for us. We're just less typing on our part. Int Alright, and then for int I 0I less than. Something's frustrated out there. Alright, array I equals in read length. Here we go. We're populating our array with the integers in the data, and we're going to yield. Okay. And again, we have a long array. This is the last one. So, all right. Oh yeah. Also, we need to. Sorry, we need to have an arrow here. I was ignoring that. Okay. All right. Again, length. Read in. All right. Even if you copy paste, by the way, you still want to have this method here because it's less code, and you're not, you're creating it multiple times. You don't want to. Trust me, you want the method. Anyways, again, long array of length. Array I equals any read long. We're basically just defining how to read the input. We're defining how to read the input, how to populate our, whatever data we're returning. Okay, so we're done now. We're done with this class, thankfully. Also, we need to semicolon there. This is a return statement. We're returning the switch. Okay. Yes, we're done with this class. Alright, so now we are in the loader finally. By the way, you don't have to do all the schematic loading manually. You can hook into the WorldEdit or FAW processing WorldEdit API if you don't want to. I personally just don't want to do that. I don't like having to do that. So I'm doing it manually. Anyways, schematic loader. Alright. So this uses a lot of NMS stuff, so we might have to actually take a pause on this and go back to do some NMS stuff. It's not that long of a class though, so let's just say I'm gonna have to end the stream here right after we finish this class, but I'll finish this method. So, well, actually, there's some stuff in here that requires NMS, and like custom objects that we create in our NMS modules. So, yeah, I'll have to end it here because I don't have time to go into all that today. Well, I don't know. I'm pretty much ready to leave. So I don't know. Let's just start and see how far we'll get. First, create a new directory. Okay, not a module in your root folder, right? Create a new directory. Call it NMS. Okay. Now go to here. Actually, don't go there. Slide. Okay. So we want 2 new modules in here. Right off the bat. So instead of clicking on this, go to the root and then click on new module. I'm gonna call this one direction. And then in the location, we're gonna put a backslash and then the NMS folder. So it puts it in the NMS folder. Because I don't know why sometimes whenever I did this in the past and I created a new module by right clicking on the NMS folder, it would also make NMS a module. I don't know. There we go. We create that. And now we have an extraction module inside our NMS folder. We're going to do the same thing here. We're going to create another module. I'm going to call it common. I'm going to put it in NMS. We create the common module. Now we have 2 common modules. One for our project and one for our NMS module. But because they're both called common, there's going to be an issue when we're trying to import them to Gradle. So we need to go down to our settings.gradle here. I'm going to move these up above our common include. And I need to Yeah, it's down here because it didn't do it automatically for us. Okay. So we're including NMS common, and after we include it, we want to say find project NMS common, and we're going to say period or question mark period name. I'm going to say equals to NMS underscore common. That way, our build system, Gradle, knows that common is not the same as NMS common. I'm going to reload that. So what is this question mark period? This is something you would be familiar with, like if you use Kotlin. It's saying, well, maybe. I don't actually know if Kotlin has this. I remember I used it in some other language. Can't remember which exactly, but it's essentially saying set the name, right? It's saying this, right? But only if it's not null. That's what this question mark here is for. If it's not null, then set the name. Right. Okay. That's good. And let's go down to our main build.gradle here. And let's say implementation project. I'm going to say NMS common. Okay. Let's see, build.gradle, let's make sure. Okay, yeah, you can't do NMS common anymore because we renamed it. It's NMS underscore common. Now, so yeah. And we actually have this one above abstraction. Mine. And you can Gradle properties, settings at Gradle. Abstraction beneath it. There we go. It's all just include order, fancy order, because common will depend on abstraction and NMS common later. Okay. So now we have this. Let's create our build.gradle or set this up for our NMS projects. So the abstraction build.gradle will have get rid of everything. It'll have our NMS Gradle plugin that we made earlier on, and all we need is to add the paperweight dependency of our base project version, and then we're going to compile only project. We're depending on our NMS common module for our NMS abstraction module. Compile only instead of implementation, because we don't want to let me see. No, we have it. Reason. Spelled wrong or something? I did. It's just paper dev bundle, not the dev bundle version. There we go. That's all we need in our abstraction build.gradle. Now in our common NMS common build.gradle, we only need the, again, our NMS, and then dependency paperweight paperweight bundle. Okay, there we go. That one's done. But it doesn't depend on any other modules. I might have skipped explaining this, or then I'm just going to explain it again just in case. the reason we're not doing implementation project like we do in our main build.gradle, yeah, this says implementation project, is because we're not trying to implement our modules into our other modules. Compile only just says, hey, this will depend on this, but it won't put it into the jar. It's saying that this is being provided elsewhere, which it is being provided by our main build.gradle because they're all being pushed in the same jar. So essentially, we're already implementing them in our main jar. We don't need to implement them in our module jars as well. Okay. So let's see, what do we need to do first? So, abstraction. So we need to work in our abstraction module. Go there, make your package. And then I do .nms. All right. And then we're going to create a interface. I'm going to call it I and MS handler. The I stands for interface. Okay. Now the I and MS handler, we want right now to have a get plugin getter. And that's it for now. We'll come back to this once we add more to our NMS stuff. There's our NMS handler, and we want, for now, that's it. Okay, and then in our actual common module, common here, and here. So in our actual common module, not our NMS common module, just our normal common module, we're going to create a new package. Oh, hold on. Forgot we need the window. Get rid of that. Okay, so again, in our common module, create a new package called NMS. And then we're going to create a new class. We're going to call it NMS factory. Okay, and in this factory, this could be a final class. I didn't make it final in my drilling code, but anyways, private NMS factory. I'm gonna make it a static only. You know, it only has static methods. And we're gonna return an INMS handler, but we can't access it because our common module does not depend on our abstraction module. So go into here, and our common module build.gradle, and please, we're gonna say compile only project NMS abstraction. And just for future proofing, we're gonna say compile only project NMS, and on both of those modules in a common module. Okay, so now we have NMS handler. We don't even need to import it because they're in the same package, despite being in different modules. So handler, there we go. Now we're gonna say public static boolean on enable. Okay. And okay, before we continue, we want a utility enum. We're going to create an enum called version in our utils package. Okay. Okay. Again, before we do anything, so utils version. We're going to create a version. Let me check Axe API, see what versions there are for 1.21.11. So it's for 1.21.11, we're going to say v1 underscore 21 underscore 8. Right. Then we're going to pass in a string, v1, 21, r7. It's weird that these are different strings. Anyways, it's like collections, singleton, list. I'm going to pass in 1 point, actually no. I'm just going to say 1.20, 1.11, like that. Okay, and we're going to semicolon there to cut it off from other enum values. Right? And then we're also going to do an unsupported enum value. Okay? Now to create our constructor for this, we're going to say version string, and this version string dot Minecraft version. Okay. So the dot allows you to pass in more strings if you want. So I can go up here and I can say, hey, 1.20, 1.10, and that'll work. But the dot parameter has to be the last parameter of the method signature. Anyways, that's that. And now we can say pivot final string animation. We're going to make a list of strings for the Minecraft versions. So NMS version equals NMS version. Minecraft versions. No, I'm going to say gets dot new array list. Actually, I'm going to say arrays as list and pass in the Minecraft version parameter. Okay, and that's our constructor. And we also want another version constructor with no parameters. I'm just going to say this string empty strings.empty, sorry. And then again strings.empty. This constructor should only ever be used for the unsupported enum. Meanwhile, all the other versions that we had should be for this constructor. Anyways, now we're going to say public not null string get NMS version. And we're going to return the NMS version. And this string get Minecraft versions. They return list.copy of Minecraft versions. We don't want them to modify the version lists that they get from get Minecraft versions. Okay, so we're only going to add one version to this enum, which is the one that we're currently building the plugin for. If you ever want to add more versions in the future, you'll just come to this enum, you'll add another version, and I would recommend checking Axe API, the GitHub, github.com/artilix-studios/Axe API, and then come down to their, find their version enum, which is inside the inside the utils, inside their API. API, you send the package, go to utils, find version. This is the I use their design for this version enum a lot. It's smart. And they have a list of a bunch of different versions from the current, even a separate paper version, to 1.16.5 is the lowest that they go. And then they have an enum for future release, and then they have unknown, which I just have as unsupported, and I don't have a future release version. Okay. Thanks, Windows. Anyways, so now back to the setup I'm going with. We're gonna have a static thing here. Public static final, not null, version current. I'm gonna open up a static block here. So this current version will be used to determine, what version we're currently on. So we're gonna get the game version that we're server's currently on. I say bucket get bucket version. I'm gonna split it. Dot split by a hyphen, and then get the first value of index 0 from that split. And then we're going to create a version v equals unsupported. We're going to set it to unsupported by default. And then we're going to loop through our versions. Final version dot values. Okay. If version dot Minecraft versions dot contains game version, then v is equal to the version, and then we can break. Then we go down, we say current equals v, and that's it. So we're saying we're looping through our versions. We're checking if the version enum up here contains this game version, which will multiply 11, which would be this game version string. Then if it is, or if it contains it, then we return that one. Now we have everything we need in the version enum here to continue working on our NMS factory. Now we go back to our NMS factory. And our unenable, we say if NMS handler is not null, then return NMS handler. We don't want to have to reinitialize all that. Or not return. True, sorry. So we don't want to reinitialize it. And we're going to say final version equals version dot current. So now you have the current version wherever we need it. If the version is equal to version dot unsupported, we're going to return false. Alright. And why we're returning a boolean here is because we're going to call this in our unenable. If it returns false, then we're going to shut down the plugin because we're not on a supported NMS version. So we're going to create a try block. We're going to say NMS handler. And we're going to cast it to an iNMS handler. And we're going to say class dot for name. And we're going to pass in our package. So I'm going to go ahead and create a string here called package prefix. And it's going to be whatever package you have. So I'm going to say io github yopping dot limbo dot nms dot versions dot, that's our prefix. So package prefix plus version dot get nms version plus dot nms handler. Okay, so we're getting the class in this specific package. We're gonna have our NMS module, which will be named the NMS version, and then we're gonna have a package in that NMS module at this location. So limbo nms dot versions dot the NMS version, and then we're gonna have a class called NMS handler inside of that package. That's what we're looking for. Okay, and we're not done yet with this. We have dot get constructor, and we want the constructor with the Java plugin parameter. We want this specific constructor that has just a Java plugin. And now that we have that constructor, we're going to say dot on the constructor. We're saying dot new instance, and we're going to pass in our plugin, our main class. We're going to say limbo dot get plugin. Here we go. We're creating a new NMS handler for this version through reflection. There's a little bit of reflection. We're going to catch exception. We're going to e print secret. So this could be any exception. It could be class not found exception. You know, whatever these throw. No such method exception, security exception, instantiation exception, legal access exception, legal argument exception, reflect invocation target exception. There's a ton of exceptions in here, so we're just going to catch it all in one generic exception. And then we're going to print the stack trace, whatever it may be. And then we're also going to say return false inside the catch block. And we're going to return true down here. We could also just say return true there. And then down here, we say return false. I don't need it in here. Either one works. I'm going to keep it how it was before. There we go. We got card catch. Now we're creating this NMS handler up here. This is just an interface, but it will allow us to interact with any version's NMS handler that we'll create. Okay, and of course we need the NMS handler, get NMS handler, return if NMS handler is null. I'm gonna throw a runtime exception. If it hasn't been initialized. There we go. So this is essentially saying either you're calling this method too soon before this method was ever called, or this method returned false, and you're on it, which means you're on an unsupported version. Okay. But now that this is done, we're going to go back to our main class, our Limbo plugin, and then we're going to say in our enable, we don't want to create the world yet. Actually, we're going to go down before the world. We're going to say if NMS factory dot on enable. I'm going to invert that. So if not on enable, then we're going to say git logger intro. You are on an unsupported version. Then we're going to return. And we're going to say bucket get plugin manager. We have a get, no. Bucket get plugin manager dot disable plugin this. We're going to disable our plugin if the NMS factory doesn't have a version for the server version that you're on, right? Man, yeah. So I was told we were going to be leaving at 4, and it's already 4:40, so I had a little bit more time than I had apparently. Either way, my mother isn't home yet, so we're all good. Okay, so that's our NMS setup done. At least for the common side, right? So now what we want to do, collapse this stuff. Nope, not that. NMS factory is done. Version equals is done. I'm gonna do this stuff down there. Okay, I'm gonna go down to abstraction. Sorry. Go back. Let me make sure I'm abstraction. We're gonna do we're gonna create a registry of blocks. I'm gonna call it I block state registry. Okay. And in this interface, we're gonna have a couple methods here. We're gonna say int to block state ID, to block state ID, and we're gonna pass in a non-null serial. Right. And then we're gonna create a couple more. Int to block state ID, block data, another one, block state. If you don't know what this is called, fun fact, this is called overload methods. You can have a method with the same name as long as the parameters are different. And then whatever parameter you pass in, it'll automatically call that specific method. That's very helpful. Hello, welcome in. Welcome in. And then we want another method, block data, to block data. We're gonna convert a block state ID to block data, and then another one, material to material. We're gonna convert a block state ID to material. This will help us store less information for the schematic. Okay. And now we want to go down to our, we want to create a version module finally. I don't like recording videos, to be honest, because it means I have to upload it manually. But when I'm live streaming, I can interact with anyone who potentially comes in. I can just ramble on. And then when I'm done, it automatically uploads to YouTube. As soon as I click end stream, it just is already on YouTube. And also it's on Twitch for a couple months too. That's why I live. I don't like having to record and then upload and wait for it to upload and all that. Thank you. Also, I'm not really an editor. So I don't really do like edited gameplay stuff or anything. But yeah, I'm doing a tutorial of sorts. Someone asked for like a Limbo plugin tutorial, like Hypixel's Limbo. But I'm doing a lot more than I actually need to. But very informative, I think. Do people find it informative? Because yeah, especially the person who asked me to do a tutorial on it. All right. Yeah, so let's create our specific version module. So we're going to be creating for the 121.8, or actually it's be 121R7. I'm going to create a module named this. I'm going to copy that. I'm going to go up here, new module, call it V121R7. I'm going to go /NMS. I'm going to put it in the NMS folder. I'm going to create a new folder, versions. All right, and create. So for this new module, and here, we go to that build.gradle. And in this build.gradle, we want our, again, we want our NMS Gradle plugin. And then the only dependencies we need are, I need the paperweight version. And even though we're only using one version, we're not going to pass in the paper version variable. Because that you might change that later. So we're instead going to copy the version explicitly. So here. I've been coding, especially in Java, for like 5 years or so. Yeah. I also have gone, I'm going to be graduating college soon. I started 2 years ago for game dev, so I've also gotten into C++ and C#. Yes, thank you. So yeah, this is not the only thing we need actually. We need our other projects here. NMS direction. NMS common. And this one actually also replies, depends on the normal common markup. Yeah, I would say so. I've always enjoyed programming. Especially, yeah, I mean, I got into it initially to create Minecraft plugins, and you know, still doing that. But yeah, the games, making games is cool too. That's really the career, is making games. Can't really make a career off Minecraft plugins. But yes. Okay. So we have our build.gradle done. Now in there, we're going to create our NMS handler for this version. So, package. Of course, we got to create our base package. NMS versions. Okay, and then v1, 21, or 7. Yep, that's our package. A little complicated, but stick with it, right? It's not too hard to follow, I hope. It's just your base plugin package right here, and then the NMS package, and then versions. We're splitting it further, and then the specific version. And in there, we're going to create an NMS handler class. There's no I at the front, just NMS handler. And this will be final. I'm going to implement the I NMS handler. And this has the get Java plugin method, or get plugin method. So, remember how we called the constructor for this in our NMS factory? We got the constructor that has a Java plugin parameter, and then we passed it in there. So that's what we're going to do here. All right, we pass that in. And then we're going to return the plugin down here. The only reason we're passing the plugin in and returning it here is so we can use this in our NMS module if we need the main class. You say this plugin is equal to plugin, and there we go. Now this is all set up. It automatically passes the plugin in to the NMS factory, and we're good to go. So, we also want a static inside this, right? We're gonna have a static instance for it. An instance, and then also in our constructor, we're gonna say instance equals this. Yeah, maybe. I'm just not really into being in the limelight of anything. I'd rather not have my face front and center all the time. So I got this little avatar down here. A little VTuber model down here. Obviously, it doesn't help with facial expressions. That's better than nothing. And yeah, I can't really help with other languages, unfortunately. I only speak English. Unfortunately, I can't cater to everybody, but that's all right. Okay. Let's see. We have our get instance. This will allow us to easily get our NMS handler in other classes in this module. That's all this for now, but we're also going to have a the block state registry, right? A new class, block state registry. Here we go. And this obviously implements I block state registry. Implement the methods there. And so the purpose of this class is to cache an ID to a specific material or block. That way we don't have to reconstruct it every time we loop through it. Yeah, I'm doing a Minecraft plugin. It's not necessarily a mod. Think of it as a server-side only mod, so that you only install it on a server, and the people connecting to the server don't have to install it. Yeah. So this class will allow us to easily look up what the block is for a specific ID. Because you have to, when you're loading through the schematic, you're gonna have the same block a million times, hypothetically. And you don't want to have to recreate the block state or get the ID from that same block every time. So instead, we're gonna cache it. So the first time we try to get it, it'll construct it. But then every other time after that, it's gonna just read from a simple map, which is much faster. There's an enum map of material, and it's gonna have integer for the ID instead of IDs. And this is material to ID. Okay. We're gonna have another map here. We say map material, sorry, integer material. And this is to store ID to material instead of material to ID. All right, and again, we have integer block state, ID to block state. This is all just so we can look up faster. It's probably fine to have 3 different maps, even though it's storing same thing, right? Again, it's all to look up and read faster. So material to ID new enum map, and it wants material dot class. It's the parameter there. That's material dot class in. Yep, it's well, actually it's 5 p.m. now. And then we're gonna initialize our other maps there. Okay, so that's done. So now we're gonna implement these methods down here. So for toBlock state ID, we're gonna say final block equals rack magic numbers, which is a bucket class, utility class. Get block, and we're passing the material. So we're getting a block from the material thanks to this bucket utility class. Okay. And this looks like it is I think we have the wrong block import here. I think that's what it's complaining about. It needs to be an NMS block. There we go. So make sure you import net.minecraft.world.level.block, not .org.budget.block. Okay. If the block is null, we will simply return -1 as an invalid block state ID, and we'll check that later. Then final int state ID is equal to block dot get ID, and we're going to pass in the block, and then we're going to say default block state from the block. Okay, and then ID to material, we're going to put if absent state ID material, and then we're going to say current material ID dot compute if absent material m state ID. So what's happening here? First, we are getting the block from the material thanks to a bucket utility class. You mean like use Claude AI to explain it? I don't think I need to. Yes. So if the If the block is null, then we're returning -1 to represent a invalid block. State ID here is from the block class, the NMS block class. So NMS block get ID from the default block state of the block. That's what we're caching. So that we don't have to keep calling get ID from and default block state, which constructs a block state every time. And then we're only putting it in the map if it's absent. So ID to material, state ID material. We're putting this material to this state ID. That's what we're mapping. And then material to ID, which is other map, we're computing if absent. What this means is if material is not a key in the map, then it'll set material to the state ID and return it. It'll also return that state ID that we just put in there. Okay. And then we're essentially doing the same thing for these other two block state IDs. Except this one's it's just a little bit different of how we get to the end goal. But we're doing the same thing. So we're gonna get a material from the block data. Get material. Alright. If material to ID needs the material, so if we already figured out the ID for this, I guess. Alright, so we're saying if the material to ID map already has our material in it, means we already computed what the block state ID is. We're going to say we're going to get the state ID from it. Okay. And we're going to say ID to material, but if absent, we're going to map the state ID to this material if it's not already mapped. I'm going to return the state ID. Right? But if we don't already have the state ID for that material, we're going to have to compute it now. So I'm saying block state. We're going to cast here to craft block data, which is like the I don't know, MS related thing. We're going to cast the block data to craft block data, and we're called get state from the craft block data. Yeah, I get that. I just don't have all the effort. And this is the wrong block state. So we need the NMS block state, not bucket block state. But actually, this, yeah. There we go. We get that NMS block state. Actually, this one seems like it wants the let's see. This wants the I see. Yep. You want a different block state. You want the org.bucket. There you go. Apparently you can not know block state. Interesting. So yeah, that's what we're doing. This one is the bucket block state, and this is the NMS block state. And the reason I'm importing NMS block state and not org.bucket block state is because we're only using org.bucket.block state here. Well, we're going to use the NMS block state probably in multiple places. And I don't want to have to type out the import for that every time. I'm not the best educator teacher for this. I'm just doing what I know, and I'm explaining what I know. And if anyone has questions, 100% feel free to ask. So again, we're getting the state ID now from the block state that we just got. All right, and then ID to material, but if absent, state ID and the material. Again, we're caching that, and again, we're gonna return material UID if absent material. C is material. I don't know why I put C. Okay, that one is filled out now. This one is block state, or org.bucket.block data to the block state ID. And this one is org.bucket.block state to the block state ID. This one is much simpler. All we're going to say is return to block state ID, one of the methods we already made. I'm going to say block state get type. There. So we're just going to return the material to block state ID from the block state, because the block state has material in it. Okay. If you have any questions, feel free to ask. I'm just kind of explaining as I go. So anyways, to block data, we have simply craft block data from data, and we say block dot state by ID block state ID. So there's already a method to get the block from the block state ID from the NMS block class. Is there anyone from Discord or something? What do you mean by that? I do have a Discord in the YouTube description. So yeah, there's already a way to get the block from the state ID. And then there's also a way to get the bucket block data from the NMS block from this bucket utility class. And of course, to material is a little more complicated. We have to get it from our map, right? So return, and we say ID to material dot compute if absent. We have the block state ID, and then we have this variable here that we're not going to use. It's an integer. I suppose we could just call it ID, since that's what it's representing. And we have to create the block data. Okay, see ya. Thanks for tuning in. And then we have to block data, the block state ID. All right, and then we can return data get material. There we go. So this is saying we're reading our ID to material map that we made above, and we're computing if block state ID is empty or absent, I should say. If the block state ID is not in the ID to material map, then it will add it to the map. It will add this material to the map with this block state ID. And it will also return this in our method. It'll return the material and map it to the block state ID. All right, and then we actually have one more method in my my block state registry for this specific version, not for the interface. And I'll tell you why in a second. So I'm going to say public not null block state new block state. and then the block state ID. So we're going to say return ID to block state, compute if absent, block state ID. And then we're going to say, we actually don't need the body, the braces, because we're only doing one line here. We're going to say block state by ID, block state ID. And we're going to semicolon down here. So this is saying, it's going to convert our block state ID into an actual block state in NMS block state. And it's going to return the block state if the block state ID is already in the map. Otherwise, it'll add it to the map and return this. And the reason we don't have to say return down here, like we did up here, is because we're not doing the braces. It's a single line lambda. And that's why you also don't have a semicolon right here, because it's not in a body. This is actually a parameter, sort of. The lambda, it looks like that. But I just put it on a separate line in order for a little bit more clarity and readability. That's we're done with this class now. And we can make this final. Okay, so this will allow us to easily read and convert to and from block state ID. Like when we're loading the schematic or sending it to a player. And we also want in our NMS handler, go to the interface, we're going to want a not null I block state registry, get block state registry. And we can actually probably just call this the get block state registry. Don't need to get. I'm also going to say dot plugin instead of get plugin. That means obviously we need to turn get from this. And we need we need to define our block state registry. This is our NMS handler for our specific version. We're gonna add another variable of I block state registry. And down here, I'm gonna say block state registry equals new block state registry. And of course, you can override the method. And then we're gonna return simply block state registry. So now we have the implementation of block state registry to use elsewhere in our plugin. And I didn't mention it yet, but the reason that this method is not in the interface right here is because it returns an NMS object, which is version specific. We don't want to deal with version specific code outside of our version specific module. So we can't have this object in our interface, because that means it will be a version specific interface, and that defeats the entire purpose of creating a module per version. So yeah, so it's done. Let's say registry. All right. We should well, actually we don't have it yet. We don't have everything we need for the loader yet. We want to go to yes, exactly. If you ever played Hypixel, they have a little lobby that they send you to when you're AFK for too long. And it's just a world with a little schematic pasted in. And then when you move around, it sends you back to whatever lobby you were in previously. Alright. So we're gonna do a fake block handler. So what that is a, let's go to abstraction. Go to, again, abstraction down here. We create another interface. Create block handler. All right. In this interface, we're gonna say, we're gonna have a couple methods in here. Quite a few actually. We're gonna have a with right container. The void method. It takes in. I don't know why I put final in the interface there in my example, but it takes in a player. Nice. That's very cool. And it also takes in a consumer. And actually we need another, we call it action. Okay, so we need another object, unfortunately, and that is going to be in our common, NMS common. Why am I making the Limbo plugin? Someone asked me to do a tutorial on it. Let's see. I'm just opening another tab here. Okay. So utils. Okay. So in our common NMS common module, finally using it, I'm going to create our base package. And we want the, yes, it's just that. We want a utils in here. And then we're going to create, I believe I just did, yes, chunks package. Okay, so in the chunks package, we're going to create a class called chunk key. And this is a simple class to help us convert coordinates to chunk coordinates and, or well, not chunk coordinates, but we'll pack the chunk coordinates into a single value, single variable. And again, make the constructor private because we don't need to create multiple instances of it. We're going to get a long, and this will take in two integers, which will be the x and the z coordinate of the chunk. Right, and this is going to use a bit of bit packing. So we're going to return, right? Return in parentheses, and then another pair of parentheses. We're going to pass it to a long. I'm going to say chunk x, and then we're going to shift it left by 32 bits, right? And then we're also going to say or, or operator, bit or, chunk z, and it's just this long string of s and an l to signify that this is a long. Right. Without the L, it's not a long. Makes it a long. It's a the value. I don't know the exact details. I'll be honest. It's like a hexadecimal value. Yeah. Think of a hex code, but also with an alpha value at the end. Think of it like that. That's what it looks like. Okay. Anyways, public static int get x. So now we're gonna take the key that we get from this method and return it. We're gonna get the x coordinate from the key. So we're gonna catch it to an int. Say chunk key. I'm gonna shift it right by 32 instead of left. Alright, and then same thing here. Get z. I don't want chunk key. I'm gonna return. And we're just gonna cast it to an int because we didn't shift it or anything. Alright. if you want more information on what this is, I would just have to recommend looking up bit masking, bit shifting, uh, those two topics. I haven't researched it myself, so I'm not confident enough explaining it, to be honest. But yeah, but what this allows us to do is, instead of storing like an object that has an x and z value, we'll simply store a long. So we're not storing an object with two integers, we're storing one long, which is a bit more efficient for space, for memory, and for lookups from a map. Okay, so we're gonna go and create a little storage system here to store blocks per chunk section. So we're gonna say fake block container, and this could be final. We're gonna say public static final int empty. So we're gonna create an empty fake block container, or empty block. An empty block. That's what this is. I'm gonna rename this to empty block. Okay, and then we're gonna have a static int create empty. This will create an empty array for us. So final int out new int 4096. So what is 4096? Why do we have 4096 here? Well, if you recall how Minecraft handles their chunks, a chunk is a 16 by world height, which is 384 blocks, by 16. If you've ever played Minecraft and enabled chunk borders, you can see them. A chunk is a 16 by 16 on the X and Z axis, and then the Y axis is 384 blocks, which is however tall the world is. Right? But this class that we're in right now, that we're making, is not storing it per chunk. It's storing it per chunk section. So what is a chunk section? A chunk section is a 16 by 16 by 16 area. The chunk is comprised of 24 different sections. So what is 4096? How does it relate to that? Well, if you math, 16 by 16 by 16 equates to 4096. So we're creating a section with 4096 blocks, because that's how many blocks are in a section. Yeah, that's how many blocks are in a section. We're creating an empty section in this empty method, the create empty method. I'm gonna go ahead and rename this to just create empty, just for the sake of naming conventions. Okay, so to create an empty section, we have to initialize this array to empty blocks. I'm gonna say for int I 0. We're gonna loop through every block in this array. Out I equals empty. And the reason we're not just putting -1 here, and instead using a static final int to represent an empty block, is that way you can quickly change this up here and not have to worry about changing it in multiple places. And then we're going to return that array that we just made. Okay. So now we're going to have another field member here, a variable. It's going to be an atomic integer array. So instead of a normal int array of blocks, we're using an atomic integer array. This allows you to, I think it's more thread safe, so you can, like, multi-threading or asynchronous operations on it, because we're going to be dealing with packets. Packets are not on the main thread. If you're confused about that, well, computers run obviously with CPUs, right? CPUs handle math and tons of lightning fast calculations. Like tons of different lightning fast calculations. The GPU is a little different. The GPU handles massive batches of the same calculations. But we're not worried about the GPU. We're only on the CPU, right? Threads. A CPU has a lot of different threads that it comes with, and it has cores and core subthreads and all that stuff. A server, a Minecraft server, runs on one thread. It's just by design. That's how it runs. It runs on one single thread, which is called the main thread. If you do too many calculations on the main thread, it will slow down the server. And we, as plugin developers right now, we're creating this plugin. We are not going to be doing, we're not going to be purposely running anything async or multi-threading, because we don't need to. But we are messing with packets. We're going to be listening to packets and sending packets. Those are not ran on the main thread, so we do need to allow thread safety. Okay. Hope that helps explain a little bit better. If you're not familiar with multi-threading, I would recommend looking into that. It essentially, when you're on one thread, each line of code runs after the other. But if you have multiple threads, then it runs those threads in parallel rather than one after another. Or it runs the code in parallel on a different thread. I hope I explained that well. I'm not the best at explaining things. Yeah. So let's create a constructor here. We're gonna initialize blocks. Get a new atomic integer array. And again, we're gonna allocate 4096 blocks as the length of the array. And again, we're gonna loop through, make an empty section. Blocks set I the empty block. Okay. So now whenever we create a new section, it's automatically creating an empty array for us. All right, and then void put. We're gonna have a position key. And we're gonna put a block state ID at that position. I say blocks set pose key and to the block state ID. And I'm not 100% sure what the and masking, the bit masking does here, but I would look it up. I just haven't got to look it up. That's the thing, but I don't know 100%. Yeah. So this is set. So what is a pose key? Short for position key. You should probably recall. Obviously, we are storing blocks in this block chunk section. I'm gonna go ahead and rename this so it's more clear. Big chunk section. There we go. So the chunk section has blocks. It has 4096 blocks in it, but it doesn't store them by XYZ. Because why would it? Instead, it stores it in an array from ID from index 0 to 4095, which is a length of 4096. And what the index is a coordinate relative to the chunk section. So there are coordinates in different spaces of the world, right? You have world coordinates, which is coordinate relative to the world, which is your typical coordinates. Then you have coordinates that are relative to the chunk. So from x 0 to 15, z 0 to 15, y 0 to 384. And then you have coordinates that are relative to the chunk section, which is, again, x 0 to 15, z 0 to 15, and y 0 to 15. Because you can't go outside the chunk. So it's relative to the chunk section. Right? If you were to move a block, if you had a block at x5, z5, y5 in the chunk section, if you move the chunk section up one, that block will go with it because it'll stay in the same relative position, right? Relativity. What else should I explain here? The pose key is exactly like the chunk key. We're gonna compact the x, y, and the z value that's relative to the chunk section into a single short. Not a long, like the chunk key, but a short, which is less data than a long. Okay. So then we're gonna say public void. We're gonna say public int get. We're gonna pass in the pose key to get the block from. So we're gonna say return blocks get pose key and 0x. There you go. So essentially we're just reading and writing from the map. Make sure you are a bit masking. Alright, and then you say public void remove. And when we remove it, you have to set it to something. You can't just remove from an array. Like you can't remove that index. So we're gonna say pose key, of course, and we're gonna set it to an empty block rather than like, rather than setting it to nothing. Okay, we say public boolean. We're gonna say is empty. And how do we know if it's empty? Well, we look through it. Okay. If blocks get I, not empty block, then return false, because it's not empty. Otherwise, you're going to say return true. Yeah. If every block in the array is equal to -1 for our empty block, then it's an empty chunk section. And then we have a clear method. We can clear the chunk section. Blocks set I empty block. Clear it by setting every index in the array to an empty block. And then we're going to have an int array, and we say view. So what is a view? Well, it's going to return a copy of our array, but it won't be an atomic because it doesn't need to be atomic since we're creating a copy of it. We're going to say int out new int without the sense. We're going to say for int I 0 I less than 496 I plus out I equals blocks get I, and then we're going to return out. So the view is we're getting a view of our blocks array, but it's a copy of it, not like a modifiable array here. Okay, that's our fake chunk container, but we're not just storing chunk sections, we're also going to store the sections in a chunk container. Okay. Okay, so yeah, we're gonna create a big chunk container. And I'm gonna rename this to chunk section container. Right? Just to have it all good naming convention. Okay. So this will have a concurrent hash map. Of integer, and we'll have big chunk section container as the key. I call this sections. The big chunk container is storing chunk sections, and the big chunk section container is storing blocks. Okay, does that make sense? Okay, so why are we using a concurrent hash map? Again, thread safety. That's what the concurrent part of the concurrent hash map is for. Otherwise, it's a normal hash map. You don't have to worry about it acting differently. It's just internally it acts differently for thread safety. That's it. The way we use it is the same. So, fake chunk container. We're going to create a constructor. We're just going to set sections equal to a new concurrent hash map. Or you could say that if you don't want to construct, if you don't want to make a constructor. But I like having a constructor to initialize variables. Okay, I'm gonna have another isEmpty method, and this is much more simple. Let's just say return sections is empty. Okay. I'm gonna have a clear method, which again much simpler. Sections clear. Okay, we're gonna have public nullable fake chunk section container to get the section container. Get section. Pass in a y value. The y value will be from 0 to 24. I'm going to call it y section just so we know it's not a y coordinate that we're asking for. It's a chunk section index that we're trying to get. It would actually make more sense just say section index instead of y section. The section index from 0 to 24 or 23. Yes, because there's 24 sections total. Okay, and we're going to say return sections get x. Okay. And here we could say public not null fake chunk section container. We're going to say get or create section. Section y. Actually, section index. Right. So we're going to say turn sections compute if absent section index S to stand for section new big chunk section container. So again, compute if absent, it will return the value at section index, and if it has no value at section index, it will put this at the section index and return that. Okay. So now we're going to say public void put world, right? So final int world x, world y, world z. And we also need to say which block we're putting. If it has a block state ID. So, fake chunk section container. Sections. Compute if absent. And we're gonna say, I'm actually just gonna say get or create section here. And we can't just pass in world y. We have to say world y and bit shift to right by 4. I believe this is like a division trick. Okay, so this will create or get the container at that y section. This is the section index, so leave it like that. All right, section index That's what that is. That's how you convert a world Y coordinate into a section index. Because there is no chunk relative Y. There's only chunk section relative Y. Because the chunk is the world height in the Y, right? So we're going to say container put, and we're going to create another class called pose key, but I'm not going to put it in chunks because it's not a chunk thing. I'm going to say blocks. New package blocks. I'm going to say pose key. Just like the chunk key class, I'm going to have the pose key. Let's see here. I put it in pose, a pose package. Anyways, private class pose key. Private class, sorry. Private constructor, there you go. That's final, okay. Public static short. We're returning a short for the key. Okay, so to pack this down, to pack these three integers down into a single short, I'm gonna say turn short, cats, the x and 15, and then bit or z and 15, and then shift that by 4 to the left. This might be a little too hard to read, so I'm going to go ahead and say local x equal z equal y. So here's what I'll do for you. Local x is x and 15. Okay. Local z is z and 15. Alright. Right. And also these. It's their passive layer. Okay. And then y is the same. It's y and 15. Shifted 8 to the left. 8 bits to the left. So what we do with that is say return short local x equals z equal y. And you have problems with that. I think we want this all to be like that. Put those all in parentheses. So we're casting the result of that. Okay, so that's basically what this is doing. Let me explain, right? So we have an x value. Imagine x is like, well, yeah, the world x. Right? So imagine x is like 1053 or something. We can't store that because that's not relative to. Can't store a non-chunk relative coordinate. Can't pack that down. Instead, we packed that, or we convert it to a chunk relative coordinate. Instead of like 1050 something, it's between 0 and 15 now. So that's what this is doing, the masking. Right. And perhaps that's what the other and operators are doing as well. And then z, same thing, converting it to a value between 0 and 15. And we're doing the same thing for y, because we're not storing it in the chunk, we're storing it in the chunk section. So it's also relative to the chunk section, means also between 0 and 15, right? Inclusively. Right? And then also, after we convert it, we're shifting it. So shifting it left 4 bits, and then shifting it from left by 8 bits. We're packing it down into a single short value. And now we need the way to get the world coordinates back from it. And I'm going to say pose key. So this is just return pose key and 15 because we didn't shift x at all. We don't need to shift it here. get Z. We did shift Z though, so we have to say return pose key. And this one has 3. But shift it back and mask it by 15. Yeah. Hit Y. Turn pose key 8 and 15. Right. There we go. Now we have our way to convert it from 3 coordinates into a single value, and the single value back into the 3 coordinates. And then there's another format actually. I believe there's like a, I'm not sure where it's used. I think it's Minecraft how they format it. So we're actually formatting it in our storage differently than Minecraft stores it. We have a class section formatting. And this will be public static short. We're gonna do the same thing, except a little bit of a different format. Why am I not using the same format to begin with? I don't know. I tried to do it. I think I just failed. Let's go on here. Oh, right. Get. So, we're gonna do the same thing. Is this? Except we're gonna shift these values around a little bit. So X and 15. Except this will be shifted 8. Okay, Z is still shifted by 4, but Y is not shifted. So we're switching those around. And then this order remains the same. X, Z, Y. Okay. Now we're going to say return pose key 8 and 15. So we're again doing the same thing, except just different values are being manipulated or shifted. And then public static get Y and pose key and there we go. This is a different format that we will use when interacting with not power storage. We'll see. Okay, so it's done. All right. Now, back here, back to our big chunk container. So in the container, we're going to put the pose key get world X, world Y, world Z. I'm going to put the block state ID. There we go. And we're going to now have a get method. And the only reason we're saying get world set world is because we're passing world coordinates. It's more explicitly obvious. So now we're going to get the block state ID at that position. So we're not going to get or create, we're just going to get. And just a little more clear for you, I'm going to make a second index here. If container is null, then we're going to return fake second container.empty block is -1. Because if it's null, that means we're not storing it, but means most likely empty. Otherwise, we're going to return container get host key get world x world y. Okay. Simple stuff here. And then the remove. The remove method is going to do a little bit different stuff. Okay. So we're going to remove the final int section index world y. Sections get section index. If section if container is null, then we're going to return and do nothing because there's no block there already. And then we're going to say container remove host key get world x, world y, world z. So now we're removing that block from the chunk section. And then we're going to say if the container is now empty, then we're going to remove that section from our map. Because if it's an empty section, we don't need to be storing it an empty section. It's less, some more data that we don't need to store. So, yeah. Okay, so now we're done with this class. So to lay it out, we have a big, chunk container that stores chunk sections, and chunk sections store the blocks. That's all we're doing right here. Okay, and now we need a fake world container for the chunks. Again, it's going to be the same setup as the chunk container. So, return hash map long fake chunk contain containers of chunks, not chunk sections. And I'm going to say chunks. Public fake world container chunks new return hash map. Okay. And I'm going to say public boolean is empty. Return chunks is empty. Clear. Chunks clear. Not return. This chunk's clear. Now we're gonna have fake chunk container. Well, actually, we have fake chunk section container. No, I lied. Yeah, I was right the first time. Container. Get chunk key. Remember, the chunk key is what we're storing as a key here. There we go. Public big chunk here, big chunk, and we're gonna pass in the chunk x and z. That way we have the option to pass in either the chunk coordinates or the key. All we're gonna say is chunks get chunk e get chunk x chunk z, like that. You still need to pass in the key to the map. Alright, and then just like our section, we're gonna have a public not null. Okay. Get or create chunk. Sorry about that. My little brother came and asked me if I wanted a Jolly Rancher. I said sure. Okay, so get or create chunk. We're gonna say file long chunk. We say return chunks cute if absent. D standing for chunk, new fake chunk name. again, view if absent, return a value or put a value in there if it's absent. Okay, so now we have we have to have a set block and get block method pretty much. Same thing as our section container or our chunk container. We're gonna say void put world again because we're on the block state ID. And so now we're gonna pass this to our chunk container. So get or create chunk key get x or y world z. Nope. Black world x world z. Okay. And then container put world x world y world z. And block state ID. Simple. We already did all the other logic. So we already did the logic to get the chunk section that block is going to go in. And we already did the logic to put that block into the specific index for the array chunk section, array of blocks. Okay. Get world, again, something, world x, y, z. Okay. Now we're going to get the block there. So final chunk container, chunks get x or z. Okay. And then we'll say if container, let's return container null. Got empty block. Otherwise, container get x or y or z. So what are we doing here? We're saying if the container is null, then return an empty block. Otherwise, return the block at this location from that chunk. Right. Which passes this through to the chunk section, if that chunk section exists. Otherwise, it also returns an empty block. And then that, obviously gets the block at that index. Okay. And then a public void remove world. Alright. So we got the chunk key. Right, chunk key. Get world x, world y, world z. There's a chunk key. Big chunk container, insert container. Right, I keep reading. I don't need the y there. Chunks get chunk key. Okay. If container is null, I'm gonna return and do nothing because the chunk is already empty. And then we're gonna say container remove world x, world y, world z. If container is empty, after we remove that block, we're going to say remove that chunk from our map, because again, we don't need to store any information for an empty chunk section, or well, yeah. There we go. So now we're done with this class. So we basically made 3 different containers: one to store chunks for a world, one to store chunk sections for each chunk, and one to store all the blocks for each chunk section. There you go. Okay. So now we should be able to go back to our fake block handler finally with right container. We're gonna pass in instead of a an unknowable generic, I'm gonna pass in the fake chunk container. And I'll show you why this method is useful a little bit later when we get to that. And what a consumer is when we get to it. And we're going to create some more methods here. We're going to create a generic method. So how do we do that? And what is a generic? Well, let me show you. So I'm going to say T, and you're going to obviously say what we're returning, right? We're returning a not null value of T. This defines that it's going to be generic. And then this is the same thing you define the generic variable as, or what have you. And then we said with read contain, I'm going to pass in again player. I'm going to pass in the chunk key. I'm going to pass in the section index. And I'm going to pass in the don't need it to be final. For an interface, you don't need to put final for parameters because it doesn't carry them to the overridden methods. But not null does get carried over. So this is going to be a function instead of a consumer, and I'm going to say int and then t and action. Okay. Oops. So again, I'll show you when we get to actually implementing the method what a function and a consumer is, and generic as well. Okay. So then we're going to have a boolean is big block, testing the player, row x, row y, I'm going to collapse this just a little bit like that. That's fine. Int get big block, not null player. Okay, int world x, int y. Use the same signature. Int get big blocks, null player. World x, world y. These. Or actually, we don't. We actually pass in a key and a section index, of course, because this is getting all the chunks for a section. And then we have remove big block, player, row x, row y, row z. So we have just basically a lot of methods to mess with our stuff that we just made. Yeah. And I'll say void remove big blocks local, player, chunk key, section index, and I'll have a short collection from Uname DSI FastUtil from the FastUtil library that's built into Paper, I think. Because I didn't implement it to my own project, so Paper did. I'm gonna say local keys. All these methods, we might not even use them, so if we don't end up using them, we'll probably remove them later on. So don't worry too much about this. And then we're gonna say void clear fake blocks. Clear all of the fake blocks for the player. Actually, we're gonna pass in offline player here. Okay. And then we have a few overloads down here. I'm gonna create a region for overloads. I'm gonna say defaults int get big block. What is default? Get big blocks. No block, yeah. So what is default? This is specific to an interface. It allows you to define a method in an interface. So normally you can't define a method in an interface, but default means that, hey, this is the default implementation of this interface. You can still override it in the implementations, but you don't have to. And it's very useful for stuff like overload methods. So this takes in a player, think we need this stuff. These ones. But there is one that we could do. Get big blocks. Instead of the chunk key, we can pass in the 2 chunk coordinates. And of course the int section index. So this would say return get big blocks players chunk key get chunk x chunk key and section index. There we go. Now we only have to implement this get big blocks up here, and then this one is already implemented for us. And it's just an overload in case you don't want to pass in the chunk key here, in case you just want to pass in chunk x and chunk z. That's all overloads are really used for, just different ways to call the same method, or different methods with the same name but different parameters, right? That maybe they do different things. But in this case, it's just another way to call the same method. Okay, so now we need to go down to our implementation for a version. I'm going to create a fake block. I think it's handler. Fake block handler. Yes. We named this fake block handler. So now we're creating the implementation for it. Let's implement fake block handler. Implement all those methods. Right? So for our fake block handler, we want a concurrent hash map up here. I'm going to store per player a fake world container. Worlds. Yeah, I should call it world. Okay. And then we have an instance of our block state registry. And then in our constructor, fake block handler, I'm going to say world new map and block state registry equals ms handler get instance get block state registry. And this actually should be able to return normal block state registry, and that means that this has to be non-interface version as well. And then it'll automatically cast it to the interface when you call this from the elsewhere. Okay. So fake block registry, or block state registry, sorry. Okay, that's our constructor. So with right container. Alright, this is pretty cool in my opinion. So we're gonna get player's UID first off, the unique ID from the player. You don't want to store a player in the map. You want to store the UID, because if the player leaves, then that player object becomes invalid. But the UID will not become invalid. That never changes per player. Final fake world container. World compute if absent. The UID. New world container. So we're getting the world container for the player, and we're putting it in there if it's not already in there for that player. Yeah. And we're going to say action dot accept container. Pretty simple, pretty cool. Right? This has an issue with that. Oh, because I said fake chunk container. We want fake world container. That means in the interface, I just have to have fake world container here. There we go. So, what this allows us to do is I can go up here like just anywhere else, right? I could say with right container, pass in player, right? So imagine this is a player I pass in, right? And then I could say this here, right? I'm gonna do a comma. I'm gonna actually put this up here, and I'm gonna say container, right? So then I'm gonna do a lambda, open that up, okay? And now I can interact with the container like it's just any other variable I have. So I can say get chunk, get clear. But first you would want to say here. You want to make sure it's not null. But you can interact with it just like any other container. That's what's so cool that I can see, right? So I'm gonna say get a create chunk. Oh, why not? So now whenever this runs, it'll run this and it'll say action.accept, and we're actually passing in an action here. Action that does all of this, right? And it'll run that action for this container that we just grabbed for this player, right? It's just very helpful to interact with it. And same thing with the get read container, except it's a little bit different. So first off, it doesn't return anything, right? This returns void, but this returns something. We're gonna say, we're gonna expand this. The final key. Yeah. There you go. And you get the player's unique ID. Container. World compute if absent, UID. You know what we can do? We can do a private not null fake world container get or create, and we can pass in player. Or actually, I'm gonna do UID first. Turn world compute if absent, UID new fake world container. Okay, and I'm gonna do another one here. Fake world container get or create player instead of UID, and I'm going to say return get or create player to unique ID. Okay, now I can simply go over here and say get or create player. Okay, easy. Something down here. Get or create player. I don't have to get it to unique ID every time and do the computer batching every time. Okay. I'm going to say if well, we actually have to name this thing. I'm gonna say world. World. No, well, actually, this shouldn't be null because it's okay. This actually isn't a get or create. Sorry. Map. But world get. No. World get player. There you go. Okay. If world container is null, then return action apply to big block container create big chunk section container create empty. I'm just gonna run whatever action they pass in to that empty chunk section. Right, big chunk big chunk container equals world container get chunk at chunk key get well, actually we already have the chunk key. I'll pass that in. If chunk container null, again return action apply big chunk second container create empty. All right, now we're gonna get a big chunk section container. Chunk container get section at this section index. Right? If section null, then turn action apply big chunk section container create. Right? We could simplify this. Well, actually, nah, I don't want to create the section unless we actually need to create it. Okay, otherwise, we're gonna return. Well, yeah, right? Action apply section container dot view. There you go. So this is just reading. We're not gonna write anything to the chunk section container. So essentially we're just reading through the blocks in the chunk section. We're not modifying it or anything. Okay. So now we can go down here and expand this out. Final. Okay. So we should say final int. So let's get chunk x, and that's simply world x to the right of the 4. Same thing like getting the section index. The chunk key. Okay. Chunk. And final int second index of y. Over. Right, so we're just getting our data there. So what's cool about this is we have the read container with read container. Say return with read container because again we're reading through it, right? Passing the player, passing the chunk key, passing the section index, and then we have the container here. Now we can say if container length less than 4096 and say return false. Okay. So remember the container is an int array, not the actual, not the section container object that we made. Yeah. We say final int index. We want to get the index for this integer, right? World x, world y, world z. And we do 0x. Okay. So return container index not equal fake section container dot empty block. And we want a semicolon here. So because we already have our with read container method above, we can use that to check if the block at the position is a fake block or not. We don't have to go up here and do all this stuff again. We already did it. We can use that down here. We don't have to search for the chunk section again. Right? And if this returns an empty chunk section, then that's fine. It's gonna be empty. Okay. Now get fake block. I mean, I suppose you could do a could make this nullable and then just return null here instead of an empty section. That could be more performant. Maybe I'll do that. We can never do that. Go back to the interface and say nullable. Okay, and then back to our big block handler implementation that we're doing. We want to say, actually, this is not. Yeah. No, we want not to make this nullable. Sorry, we don't want to make this nullable. We want to make this nullable. Okay. Sorry, that's what we want to make nullable. Okay, big block handler up here. I don't know why it made it non-null instead of not null, or it made it non-null instead of non-null. That's fine. So with read container, it returns a nullable thing, so we can actually go down here to return null, return null, null. At least I think that this will work. This you would have to say well, it's supposed to, it returns t, right? So it'll return a boolean. A boolean can't be null, so I think that's why I was doing. You can do that. Suppose this is okay. Is fake equal null, then return null or is fake. Yeah, that's what we could do. But I suppose that works. That way, at least it's not gonna interact with it. It's not gonna create an empty section, at least, which includes looping through a 4096 sized array. We can do that. Okay. Get fake blocks right here. And you'll never guess how easy this will be. There you go. Oh, this is just get fake block, my bad. No, down here is what we want. Let's click that. What if it's confused? Okay. So get fake blocks is really simple. We already made the read container. Right. Problem is this is nullable. So I think that'll be fine. Can we mark this as nullable? No, because it's a primitive array. Okay. So that brings us to another point, right? It's returning this int array here, which could be null right up here. So I think I'm just gonna roll it back and keep this with the empty thing here. But yeah, that's how you could do it if you want to keep checking cool stuff. Which is not fun. Create empty. Oh yeah, actually apply to the fake empty. And then this could be not null again. There we go. Much simpler, honestly. It does do. Honestly, I've been using this for Bamboo. It's not that bad for performance. I mean, I don't know. I haven't tested with like more than 2 people, so we'll see. If it ever needs more performance, I will fix that in my prison plugin, and you can take it upon yourself to fix that on your end. Okay. So get fake block though. Let's see. this one, we're just gonna, again, since it's not nullable, turn that like that. Okay, so get fake block is gonna be the same thing. I'm gonna copy this and say, you there. Should be returning. Oh yeah, this is a boolean, so we're gonna return that instead of not equals. Here we go. Oh right, this is a boolean. It can't be a boolean there because we're supposed to be returning, and you can't return two different things. Obviously, chunk section container dot empty block. There we go. Simple. Get fake block. Again, it's the same thing as is fake block, except it doesn't return a boolean down here. And then get fake blocks simply returns the int array that we already found with root container. You don't have to do all that stuff again. Okay, remove fake block. This one's pretty simple as well. And I'm gonna expand this out. Simple. With right. Because we already have that. Container. Remove world. World X. World Y. World Z. Simple. And we don't even need the body stuff. There you go. That is very simple right there. Because we already did all the logic of reading through and writing through the different containers. Okay. And then remove fake blocks local. This is yeah, I don't know if we'll ever use this, but we'll have it, I guess. So if local keys is empty, do nothing. Okay. Then with right container player container fake chunk section. Right, actually we need the fake chunk container. Rules container, and we can call this world container. World container get chunk. I'm gonna say chunk. We already have that passed in. Okay. If chunk container is null, we're gonna return and do nothing because we don't have anything to remove in that chunk. It's already empty. Fake block. Not fake block. Fake chunk section container. Section container. Chunk container get section at section index. Okay. If section container is null, in return because we don't have anything to remove in that empty section. And now we're going to loop through our local keys, which is our chunk section keys. Okay. And then for each key, we're going to say blocks, block section container remove key. So we're removing a bunch of fake blocks that are, and we're passing in the relative keys for those blocks, not the world coordinates for them. So it's helpful if you have like you already have the section relative blocks. Good. Though I doubt people use it much. And then here we have clear fake blocks, which is not much really. So if I don't new ID get the UID from the offline player. Container get world get the UID. If container not equal null, I'm just gonna say container clear. There we go. We're clearing all the blocks for them, not removing them from the map, which we should do. So if we are removing their fake blocks, we can also just remove them from the world map as well, because they don't have any fake blocks. There's no need to store them in the map. Okay. That's this class done. And we didn't actually end up using the registry, so I don't think we need that. I believe I used that in other methods that we don't need in this project. Okay. So that's good. Of course, we need our fake block handler down here in our NMS handler. Fake block handler. I'm gonna do a little bit of this so it looks a little better. And we need to go to our NMS handler. You can hold control and click on that to go there. Then not null, fake block handler, fake block handler. And then now we need to go back here and we need to add that method. Public not null fake block handler. We don't need the I. It'll automatically do that for us. Go. And we are good to go for now. So we should be able to actually start working on the schematic loader, if I'm not mistaken. Well, that means you don't need all this fake block storage and stuff, the setup that I've done. If you're not doing with fake blocks, or you have a different way of storing the fake blocks, or you know, schematics. So I'm just showing you how I do it, at least in my Prison Core. Here, common. Go back to our schematics, schematic loader. Okay, close this stuff out for now. Right here. I'm gonna make the path final. Okay, so now we want to go and add these. Not null. Ooh, we didn't make a schematic handler. For now, we'll just say this for sponge. Final INMS handler equals NMS factory, get NMS handler, block state registry equals NMS handler dot block state registry. That's how you get it and use it outside of your NMS modules and stuff. Yeah, okay, I forgot about one of the most important things, storing our schematics, of course. So we're gonna go to, well, actually, we'll just use the fake block handler. Well, okay, maybe I'm dumb. I completely, yeah, I think I'm dumb. I don't actually need the fake block handler for this at all. I was in prison core mode copying what I was doing there. Let's just go here and say we do kind of need a similar setup, except we're not storing it per player. So let's just go back here and let's not store it per player. Store by string, and that'll be schematic ID. So replace the world with the string. Place get or create. I'm gonna say string schematic ID. Let's salvage it so we don't have to undo all the stuff we just did and do it all over again. Schematic ID. That means we don't need this. Strings schematic ID. Okay. Schematic ID. I don't think we even use get or create more than once, so unfortunately my foresight was unnecessary. So again, all we're doing is replacing player with schematic ID. While fake blocks are per player, I'm not storing any per player fake blocks. And it would be bad to store the schematic per player because that would mean way more blocks than we need to store. It's a schematic, right? Every player will see the same schematic or same blocks for each schematic, so we only need to store the blocks per schematic. Again, just go through. We'll come here and say schematic ID, and it might help actually if you just simply go to the interface first instead of player. I'm gonna just go player string schematic ID. Go ahead and replace all that. There you go. And don't need that because I'll actually say instead of perfect blocks, remove schematic ID. There you go. Schematic ID. Okay. And now we can go back here. Anywhere there's an error has schematic ID in. And just go through and replace player stuff with schematic ID. Yep, so just, salvages. Sorry about that, guys. I really don't need for player storage for this project. It's all good. Remove schematic string ID. And we don't even need to clear stuff. We just remove that. Because it'll garbage collect and clean up all that stuff automatically. Okay, this is done. We can remove these imports. Done. This is done. Okay, now we just need the private final not null I fake block handler. Fake block handler equals NMS handler. We got fake block handler. Okay, so now we're storing them per schematic, not per player. We don't need per player. And now you don't have to go through and create the schematic handler instead. We're just using this, which is basically the same thing. Okay. So when we're loading, we're gonna read through the bytes of the file, right? So we're gonna create a byte array. I'm gonna set it equal to files dot read all bytes of this path, the file of this path. Now we have a byte array of all the bytes in the file, right? I'm gonna say boolean gzipped. Whenever we had a little gzip thing, I'm gonna say file bytes length greater equal to 2 and file bytes 0 equal to 0x1f and file bytes 1 is equal to right, it seems to be a byte as byte 0x. I want to say that's an 8b. Or it's an 88. I think it's an 88. Let's see. Nope, that's an 8b. So gzipped is a different type of file format, right? It just has extra characters at the beginning that tells us that it's the gzipped format. That's what we're checking for. So now we can say MBT compound. We're gonna get the root compound here. So we're gonna try. We're not gonna set it. We're not gonna define it yet. We're just gonna declare it. And we're gonna say try byte array input stream. I'm gonna say b in equal to new byte array input stream. File bytes. So we're converting the file bytes into an input stream, essentially, or more specifically, byte array input stream. Okay. And I'm gonna say root equals gzipped question mark simple nbt. Remember that class we could earlier. Read gzipped and b in. Otherwise, simple nbt read b in. There we go. We're essentially saying set root to gzipped if it's gzipped, or normal if it's not gzipped. Okay. So now, remember the file format, right? Go back, schematic. Remember how the file looks? It looks like this, right? We just got the root compound. What's the root? This is the root, okay? But there's nothing else here. There's nothing after this block. This is the only block. This root is kind of useless to us, so we need to set our root to equal schematic instead. So we're gonna say root. We're gonna redefine what root is. Root is equal to root dot get compound schematic. It has to be it's case sensitive. And all right. Remember, that's the root that we're getting from the root compound. So now our root is equal to schematic. And now we can read through the schematic block. I hope that makes sense. And also I said get compound or self, not actually just get compound. Alright, give me a couple seconds here. I'll be right back. Okay, sorry about that. Just trying to check on something. Okay, and closing my bedroom door finally. All right, so I'm gonna finish off this schematic reader class, and that'll be the end of the stream. Because I mean we've been going for 5 hours now, and I think it's good to take breaks. And we might be leaving. I don't know, but also dinner's been ready for the past like 10 minutes. So I think it's a good place to just end here after we finish this reader. Which luckily there's no other methods we have to create. It's just filling out this method here. So we have our schematic. Our root compound is now at the schematic header. Or section, you can call it. So after that, we have to get the information of the schematic. Again, remember our schematic format. After we're in the root section right here, now there's a version, data version, metadata. But when I tried to read this stuff, it broke. So I don't think that it's actually in the file. So I skip over this entirely in my implementation of my file reader. See right here. And we just go straight for getting the width, height, and length, and offset. So that's what we're gonna do. We're gonna read the width, height, length, and the offset. Okay? Because that's what's next after the schematic. So we have the width and height are a short. Again, here, let me just keep this over here. The width and height are unsigned shorts, which is just short for us. Okay, and then the length is also short, but the offset is an integer of three integers, integer array of size 3. So again, we have short width is optional dot of nullable root get short width, okay, dot or else cast short to 0. Cast 0 to short. So we're saying if root dot get short width returns null, then we're gonna set it equal to 0. Okay, that's just a little easier than doing the than defining a variable that like a nullable short variable. Right. So let me just clarify. Right. So root height, root get short. Right. Then we would have to say short height equals root height null. There's a lot more to write out. So instead, we're gonna go this way. We're just doing optional nullable, essentially. Right? That's what I mean. We would have to do this if we didn't use the optional. Essentially, that's what this is good for. We didn't have to define a non-primitive short variable and then manually check if it's null. Okay, and now we have the offsets of nullable. Again, root get int array offset, or else new int, and we're gonna say 0, 0, 0. Right? So what am I doing here? If getting the offset from the compound or from the root compound is null, we return a new int array that is initialized with the values of 0, 0, 0. Okay? That's what this is doing here. Saying new int array, and we're opening up a body, and we're defining what's in it. Right. Alright, so we have those values of the properties now. Now we can use the file name to check the, well, for logging. I'm gonna get the file name for logging purposes. Path get file name by QString. Okay. Now we have it for logging purposes. Now we need to see, okay, so what's next in the schematic? Well, blocks is next. So now we need to get our blocks compound, right? So now we say npt compound blocks equal to root get compound or throw. Because there's blocks sitting in there, then we're gonna throw and say, hey, we can't store the schematic in the blocks, right? And then we're gonna pass in, we're gonna get the blocks compound. Okay? And then if it's null, we're gonna say blocks tag missing from schematic, and we're passing the file name as well for better logging. Then we'll know which schematic format or which schematic in our folder is broken or something. Okay. And we also need one more compound. We need the palette compound. And then we're going to get that from the blocks tag, not the root tag. So we'll get, then it's going to be palette. And we're going to say palette tag missing from schematic. So again, the blocks, how do we know about the palette, right? So we can go back here. Why does it keep going all the way to the top every time I click on the tab? I don't know. It's really annoying. Blocks. It's a block container. And what's a container? Well, where is that at? Where does it say that? Block container, right here. The block container is another compound, right? So it has a palette, data, which is a varint array, and block entities, which is an array of block entity objects. So now we're at the point where we're reading the palette. So we're reading inside the blocks compound. We get the blocks compound from the root compound after we get this information. And then we want to read through the blocks. That's how we know what the schematic is, right? And you read through blocks. So, what's a palette? Well, a palette tells us what blocks are in the schematic. So a palette object is up here, and again, it's like a map. So you got air, you got 0 blocks of air, you got 1 block of oak planks, you got 2 blocks of custom, or this is just the ID in the palette. I think, yeah, this is just an ID, not an amount, not a count. They do this so that way you can just store the ID in like an array of blocks, not all the blocks every time. Like, you don't want to store this string for every air block in your schematic. Rather, you want to store 0. It's less data to store. That's what the palette is doing. The palette is saying, hey, 0, wherever you see 0 in the blocks list of the schematic, that's air. Right? That's all it's saying. So we need that palette so we can decode what the blocks are, right? In the thing. So palette, right? And because we say get compound or throw, it'll throw if it's null. That way we don't have to return here or anything. It'll already throw and return for us. Okay. That's the palette tag. Now byte, call it raw data. So we get blocks dot get byte array data under okay. I'm gonna just keep you know what I'm gonna do? I'm gonna do this. I'm gonna keep you here. And in my other browser will open up you. I don't need these things here. And I'll keep this open so when I can show you guys. If I need to. Okay, right? So the data, right? We know that the data is what we read next because, again, we're reading through blocks right now. And what is blocks? It's a container block. The block container, right? So what is a block container? Well, it's right here. Again, we already read the palette. So we have the palette. Now we're reading the data. And the data is right after the palette. So that's what we're reading here. I know it says varant array right here. But I think we just use byte. There actually is no varant object in Java. I create that for my core, and Minecraft creates their own custom varant object for storage as well. But we don't have that here, and I don't use that in my schematic reader for my Prison core. So this should work just fine, right? So it's a byte array. Let's say if raw data is null somehow, throw new illegal state exception. It tag is missing from schematic file name. Okay. Don't have to return because that's what the throw does. Then we can say final. I'm gonna use a map from the fastUtil here. FastUtil int, right? It's called int to int map. So it's just a map of integer keys and integer values, except when you normally use a map, you can't put primitives in it, right? You can't do this. You have to say integer, which is the non-primitive, which is an object. I think the int-to-int map uses primitives instead. So yeah, so we're gonna call this int-to-int map palette. It's gonna be a new int-to-int open hash map. Okay. Oh, we already called it palette. That means up here I'm gonna call it palette tag, and this blocks tag. Okay, so the palette is the map, and I'm gonna say palette dot default return value is gonna be container fake chunk section container dot empty block. So the default return value. So if we try to get something from the palette that isn't in the map, it'll just automatically return -1. Don't have to worry about that. Okay, so now we have to loop through our palette tags. We say b set from the palette tag. So what we're doing right now is we're gonna populate this palette map with the values from the palette tag. So it's gonna be like exactly as you saw here. Palette like this. So like this is gonna be our key, and this will be our value. Except we're not gonna store the string as a key. We're gonna convert this to a block state ID that we made previously. Remember block state registry? And then we're gonna convert this to we're not gonna convert this. I mean, this is just local, palette data. We don't need to convert that, but that's what we're storing as the value of our block state IDs. So I would say if key equals Minecraft : __ reserve __, then we're gonna continue. We're gonna skip that. Apparently that is a key that is a key there. See my dictionary. Okay. And we don't want to try to convert that. It won't do anything. So I'm going to say integer ID palette tag get int key. Okay. If the ID is null, we're going to continue. Do nothing with it. We're going to get the block data here. I'm going to say try. Block data equals bucket create block data from the key. There's a catch illegal argument exception. I'm just going to continue. We're not going to print it. We're just going to ignore it. And final material I'm going to convert that block data to the material. Now, if material is air, we're going to return. Not return, we're going to continue, sorry. If we return, we would skip all the other blocks. Because we don't want to store air. So we're going to say palette put id.int value to block state registry to block state ID in the material. So actually the key is going to be the value of the block palette, which is like a key of like what block it is, and then which is why we're making it a key in our palette. And then the value is going to be our block state ID, so we can look up what the block state ID is according to the palette ID. Okay. And then this is the last part of the method here. We're going to say final byte array input stream. I'm just going to call it in. With new byte array input stream. I shouldn't call it bin because I called it bin somewhere else. We're gonna pass in the raw data here. This is a byte array. We can read through it with the byte array input stream. Schematic ID equal to path to string a substring path to string again pass 0 in like -6. That's again we're removing the .schem from the file name to get the ID of the schematic. So now we're going to say big chunk container equals big block handler dot get or create right, and we need to add this method to it. And I'm going to say schematic ID because we need to redo it. Or actually, maybe we don't need to do that. We just need to say big block handler right with right container schematic ID and container here. There we go. This should do it just fine. So now we need to loop through our height, width, and length. So for int y equals 0, so we're going to start at 0, y less than height, right, and then y plus plus. So we're looping from 0 to the height of the schematic. And same thing here, z is 0, z is less than length, and z plus plus. Okay, and then again, int x equals 0, x less than width, x plus plus. Okay. Now we need to get the palette index for this XYZ. Okay, so this is interesting. Now I have a read varant method here. I'm gonna go back to I have it like a schematic utils that read varant. It's very interesting. I don't know why. I'm gonna have to clean up. I gotta clean up some of my code in my core. There's some stuff that I have like 2 of, like the read varant. It's not wanting to load the page. Great, thank you. Thank you for that. Read the page, please. I'm real annoying with this. Okay. Let's see. This page would fine in this browser. Okay. Where did schematic utils go? I put it into files, okay. So we're just gonna do a simple like read varant in our common stuff, let's click this little button here, select open file. Easily open our stuff up here. And we'll say, let's go here, say var int. Okay. Private var int. Okay. And then we'll say, public static int read, as in the byte array input stream. Okay. The value, we're going to define a variable called value, set equals 0. Same thing with a value with a variable called position. So we're going to say while true, we're going to say int current equals begin dot read. We're going to say value type equals the current 0x7f shifted to the position left, shifted left to the position. And then we're going to say if current and 0x80 equals 0, and we're going to break. And then we're going to say position plus equals 7 to move 7 bits. And we're going to return the value. This will allow us to read a var exact use case right here. Okay, so the palette index, we're going to say var int read. We're going to pass in again begin. Okay. Then we're going to say final int block state ID equals palette get palette index. Okay. Alright. Now if block state ID is equal to big section container dot empty block, we're going to continue and do nothing with that. Alright, and now we're going to say final int world x equals x plus offset of 0. Remember, we have an offset. World y equals y plus offset 1. Z, also it's plus 64. Well, I'll leave that alone. Z equals z plus offset 2. The reason I did plus 64 in my prison core is because I'm pasting all schematics at 0640 in my void world. So I just do it there, but we can do it elsewhere. Well, no, we can't, because we're not doing anything with the blocks of the schematic besides moving them immediately to storage in a coordinate stored place. So it has to be set up here to be where we want it to be. Right, and I'm going to say container, put world x, world y, world z, ID. If you want to be a little bit faster, you can actually move these up out of this X loop. You could do this. That way you're not redefining world Y and world Z every X block, every Z block, or whatever. You could do that. There you go. There we go. Now we're reading the schematic and we're putting it immediately into storage. Now then when a player joins and they go to Limbo, we'll read immediately from storage and send it to them, which we have not got to yet. So now we got to a place where we're storing the schematic, we're storing the fake blocks. Is a good place to end it. The next stream we will start on reading them and sending them to the player, which will involve packets. It will involve packets. Oof. And we're gonna do something that I did for my prison core again. We're gonna be doing a packet adapter system, like protocol lib does. But we're not going to use protocol lib. I don't like using protocol lib. It's a whole nother API that I have to learn. I don't want to do that. The way I do it is really simple. At least for me. For me, I understand it's simple. I understand it might be complicated for you guys, for anyone else out there. But to me, it's more simple than having to learn protocol lib, because protocol lib docs aren't very well. They were, last time I saw them, they were a little complex, I'll say. We'll see. The next time I stream this, we'll start working on that. So I'll see you guys next time. This has been a lot longer of a stream than I thought it would be, to be honest, because I thought we were supposed to leave 3 hours ago. So you know, I guess it's just how my family works. They don't really they're not really on time with things. I don't know. I mean, to be fair, okay, my mom had to work, so it's fine. And I don't mind it earlier than later. It's just someplace we're going, right? Anyways, I will see you all in the next one. Thank you all for tuning in, for watching. And if you have any questions, put them in the comments, or you can join my Discord. It's in the description. And I might even link Cody Simpson's Discord at some point, because I help out in Cody Simpson's Discord with like answering questions. Not as a staff member or anything. I'm not really affiliated with Cody in any way. I'm just a member there, and I help answer some questions sometimes if I know the answer to them. So yeah, I'll leave it here. Again, I already mentioned I have a Discord. It's in the YouTube description and my Twitch homepage. If you are unaware, I stream on both YouTube and Twitch, so you can watch on whatever platform you prefer. But also, Twitch only streams in 1080, or I only stream to Twitch in 1080 because the bitrate limit. But I do stream it on YouTube at 1440p, so it's a little higher quality there. If you're interested in that, you can go watch over on YouTube. And all my VODs are forever on my YouTube channel as well. Twitch deletes VODs like after like 2 months or so, but they're all automatically uploaded onto YouTube. So if you want to see any past streams, like I just did 2 Subnautica streams yesterday and the day before. So if you're interested in that, I have that up on my channel under the live tab, of course. And yeah, I do coding and gaming streams. That's about it though. And I'll see you guys in the next one. See ya.